Hello, good morning everybody to the basic toolbox training in the first digital edition in English this year. So this is the first time where we present a toolbox training online via a video webinar or online training. So let's first start to introduce myself. So my name is Daniel Mariano. I'm product and support engineer and I'm your trainer for today. To tell you all the things about the toolbox that you need to know. Yeah, let's take a small view about the topics we will touch today. In the first part of the training, we have three parts of small segments. First, some introduction stuff, basic functions and explanation about the terms that we use in our programming inside the toolbox program. Afterwards, we will have a look into the audio system. So how is the system built inside the DSP, etc. And we will touch the I/O configuration because we want to learn in today's training how to configure a mixer. So what initial steps you require in order to make a mixer work. So this is about adding I/Os, how to configure faders, so that you learn what initially to do to make a mixer work. And then, of course, we will touch how to program the mixer console. In the second part of the training, so after the lunch break, we will touch view configuration. We will make some advanced stuff about audio and logic system, that you get to know all the additional parts that are inside the toolbox. Of course, we won't touch everything which is inside the toolbox because this would just be too much for a small training like this one here. But as a first step and to get to know what to do and how it's working, this is okay. Yeah, first some words about DHD audio. Probably some of you know me and know DHD already. Others are pretty new to DHD. So DHD is located in Leipzig in Germany. So I'm currently talking inside this building to you from this point of view. The weather is not as nice as on the picture. Currently it's rainy outside, but whatever. The history of DHD started in 1994, where my two bosses, Mr. Deubner and Mr. Hoffman, created the first digital mixer. In 1996, they founded the current company, which is called DHD, which stands for Deubner Hoffman Digital. And the factory was founded. And what are our main things that we do? We produce broadcast mixers. We do everything in-house, so the programming of the software, so firmware. The toolbox is programmed here in Leipzig as well. We have the research and the development department also as well here in Leipzig in this same building. And so we have everything under control, so metal parts, etc. So we can have a good view on all the products and have everything under control, software and hardware parts. So here's just a small overview of current installations. This is only a list of selected references. The list could even be longer. We read there that there are more than 6,000 DHD installations worldwide and is still counting up. So this is just a small reference list. So in order to start, and we need to talk about some basic terms. So how is a DHD product constructed like this? So during the presentation, I will show you some things about this console. So this is the demo mixer we will use today. So this is just a control surface, how we can operate a mixer. Generally, we have three parts of a DHD system that are there and that will interact together and that are required more or less in order to make a DHD mixer and a mixing desk. So first of all, the central part that we cannot keep away, this is the DSP core. So this is that part here. So in this part we have the DSP processor inside, we have some logic controller, we have all the interfaces, so the cabling is all done to the DHD core in order to make everything work. So the central part the central processing unit is this DSP core. So without this one, you won't have any mixer. So we have just hardware which is not doing anything. Of course, every time we want to make a mixing desk, so this is the same for all mixing desks, of course you need to interface with the outer world. So we have a lot of different I/O modules. So this is one example. So this is the interface to connect analog signals, digital signals to the core. And of course, what would be a mixer without a control surface? So this is in fact what the user will be seeing inside the studio, but in the background you will have all this stuff as well. So this is one example of a control surface. We will see later that we could operate a mixing desk even without any hardware related control surface, because we could also do this with web applications or with some virtual stuff on a tablet or whatever. But in fact, these three things are most common in all the installations. Let's take a look at a standard system example. So how are things generally set up and how they are wired? So everything is based on the XC core. So we have two parts in this drawing here. We have on the left-hand side, we have the studio and we have the machine room. And this is a classical example how a system could be constructed. So the XC core, so the main part, is installed in the machine room, somewhere in the keller or whatever. The main part of the XC core is that it's either that it's equipped with the DSP processor. It has some external network interface. So this network interface that we see in orange here is connected to the not to the office network, but to the technician network. So you have a workstation connected there. That could be my laptop as well. So that we use for configuration, for maintenance, updating the firmware, etc. So this is done with this network connection. When you take a look at a core from DHD, you will see on the backside a lot of APC ports. All the connections that are painted in green in this drawing are APC connections. APC does mean we have audio, this is the A, we have power, this is the P, and we have C for control, for APC. So we do all these three things through a standard Ethernet cable. And once the wire is set up to a module, we have it connected to the core. So we can connect I/O modules via APC to the core, but we can also connect mixing consoles via APC to the system. And this is the standard connection how we interconnect surface modules, I/O modules to our cores. As the XC core has 12 APC ports, it could be that either you have not enough APC ports on the core to connect all the stuff you require for an installation, or you want to set up the system like it's shown in here. You want to have a parted system, so you want to have the core inside the machine room where you also have some audio sources like play-out machines, something else like coming from the audio over IP network or whatever. And then on the other hand, you have a studio where you have also some local sources like microphones. You need also some local destinations like headphones and talkback speakers or whatever. So you would also like to split up your system into two parts. And this is no problem because we have a part inside our system which is called XC2 concentrator. It looks very similar to the core, but this part, this device has not any DSP inside. So this is just a device which can extend your system with APC ports. And the nice thing about the concentrator is that it's connected to the core with this blue connector. This is the gigabit audio line, which is done in fiber optic. So you can place the concentrator far away, either with multi-mode fiber or even with single mode is an option. So you can place it also very far away. And due to this fiber optic connection, this is completely separated from the power. So you have a local power supply here in the studio, local power supply in the machine room, and you have galvanic isolation via the fiber optic as well. And once this is configured and connected, you have the concentrator working as an extension at a place where you like to have it. So inside the studio, here as here in this example. The I/O boxes are then connected here, so the local ones, so local I/Os like microphones and headphones, and also the console will be connected to the local concentrator inside the studio. So this is how a system could be set up as a single device, from a single device. So this is a single studio, for example. Of course, you could have also multiple studios set up like this. And yeah, we will see later when we take a look into the toolbox where we talk about the basic wording of the toolbox, how a system could be constructed, or a project, in better words. Okay, which type of surfaces do we offer? So just as a rough overview, so we have currently 5 surfaces that we can offer for mixers, for designing mixers. So the most current ones are RX2 surface and the SX2 surface. They look pretty similar. The RX2 surface has got this type of central interface with 2 displays in the middle of it. The SX2 is more or less a compact and value-orientated design. So we have different displays in here, but we offer here a small central unit with 4 faders and speaker. Common between RX2 and SX2 is that they have motorized faders, and that the central section is equipped with speaker output, 2 potentiometers, and on the back side you have a microphone input, and you have 2 line outputs, and you have also a headphone output directly at the module. So sources that are directly located at the desk and destinations that are on the desk, like speakers, can be directly connected to those devices. Yeah. We have also here the MX surface. So this is the most modular surface system that we can offer. So you can make a combination of all these single strip modules which exist in a long variant where the faders are, for example, inside. You have also possibilities to create overbridges with this one. You can add TFTs to it. You can only use the large modules for constructing a console. You can even choose just to make a console with only small-sized modules. So there's a huge variety that you can construct based on the MX surface. So now it depends. As you see, we have modularity here, and it depends on the needs of the project and the workflow, which mixer type is the best for your installation. Additionally, we offer such TX module, which is a multi-touch mixer for news desks and edit booth. You can place virtual faders on it, so the faders that you can place there are touch sensitive, but it's also taken for news desk where you just need buttons to switch on the microphone, for example, or to trigger some playout system to play the next part of the news program. And at least we have the DX desktop mixer, which has got 4 faders. There's no audio I/O at all on this type of surface, but it's pretty small. And yeah, it's taken a lot of times for like cutting desks for TV applications, because you can just place it aside just for small mixing applications. The DX mixer is suited very well. So this is what we can do with the hardware surface. But as I already told, it is also possible to have some, let's say, virtual interfaces or virtual surfaces already available in the version 9.1, which is the current toolbox and firmware version, is the so-called views app. So you can bring any content that you have configured on a surface, like these views, can also bring inside the you can also bring these inside the web. So with the web application, you can access all the types of views. This is completely configurable. Of course, you could also construct specialized views which are only made and dedicated for web applications or used to be used on a tablet or whatever. A new part which we will release with the version 9.2 in the upcoming months is the Assist app. The Assist app is consisting of 2 parts. So the first part is we have integrated the Views app inside the Assist app as well, and we have added the hardware interface as well. So you can operate, for example, a TX mixer directly from the web browser, including the buttons. The Assist app will be available for the TX and the RX2 and the SX2 can be then completely operated from the web browser, including the hardware buttons, the faders, and the TFTs. So this is a remote solution that you could also use. For both applications, you require a license in order to make use of these features, but the intention is to say that we also can offer something which is more or less virtual, which is only existing inside the scope of the web browser in order to operate the desk. Here, a small overview about the DSP cores we can offer. So I don't want to go inside this very deep because we have all these informations also on our webpage, dhd.audio. With this huge list of features that you can compare the different cores here. We have three different types of core. The first type is the 52XD2 core. So this core is the most powerful core we can offer. It is equipped with a lot of gigabit audio ports, so that you can use for extending it with concentrators, for example. You can add up to 4 DSP cards. And if these maximum of 4 DSP cards are inserted, you can operate up to 64 faders. You can have up to 48 summing buses, 30 mix-minus buses. So it's pretty powerful. And why are these stars inside here? I need to say that these are the possible maximum values because the DSP system is configured via the toolbox, and it depends a bit on which functions you configure inside the configuration. If you make a use of many faders with a lot of processing, you probably cannot use other things, because if the DSPs are completely utilized, there's nothing more that you can configure, of course. But it's pretty hard to fill up 4 DSPs with function. Another core type is the XD2 core. We have several flavors of this core. So the XD2 core is this one here. So it's just a single device with 12 LPC ports. We have 4 gigabit ports. By the way, these gigabit ports can also be used as MADI inputs. So this is either a gigabit extension with a concentrator or a 512 channel audio link, or it can be also MADI input. So with a single MADI SFP module, you can make a MADI port as well out of it. This type of core can be equipped with 2 DSPs. Standard, when you buy it, it's just with 1 DSP equipped. So in the standard way, you have 24 faders available if it's a 7420 core. If you upgrade it with a second DSP, you get a maximum of 44 faders with 40 summing buses and 48 level meters. And there's also another type of core, this is 7423, which is upgradable with licenses, and the newest member is currently not listed in here. This is the 7424 core. And the nice thing about the 7424 is that you can buy it, it also looks like this one, but it starts at a very small amount of processing, so 16 faders, but you can upgrade it with licenses. And you also can add a DSP card. So you can upgrade the 7424 core to be as powerful as the 7420 with 2 DSP cards. But the 7424 is, when you start in a project, you can just place it in there and can see how far you can get. And if you have the requirement later on that you need extend the studio for any reasons, you can do it just by adding some licenses or adding DSP cards. And so 7424 is very versatile. And last part of our current cores is the 8013 core, which is looking like this one. It has integrated some audio interfaces already on this left-hand part of the core, and we have some APC ports as well. So this is for smaller applications. Of course, we have also gigabit ports in here, so even if the number of 4 APC ports is not enough, you could extend it with 1 or 2 concentrators in order to have even more interfaces connected. As an example 4 I/O modules. So for the interface into the audio world, so we are inside the digital mixer, and we don't care what's outside, but of course we need to interface with the real audio world. So we offer several I/O modules to do this. So we have line I/O modules, we have a combination of microphone and headphone modules, so 4 microphone inputs, 4 headphone outputs. We also offer a SDI de-embedder, and an embedder, so we can de-embed the audio signal from a video signal, and we can re-embed it to the video signal as well. So we don't modify the video, but we take the audio. We also offer digital I/O modules, which can operate with AS3 compatible signals. Of course, we can also take SPDIF on these modules. We offer also specialized 8 times microphone or line input. And also we have the other part, the output part, with 8 analog outputs with this I/O module. In installations where you have not so many I/Os, maybe the multi-I/O box is the best choice, because the multi-I/O box is the I/O box where you have the highest density of inputs and outputs inside the box. So there are digital I/Os, we have a separate SPDIF I/O, there are always GPIOs. On all the boxes we have GPIs and GPOs available in order to make some wiring for red lights inside the studio, etc. Or GPI I/O's general interface to any external switching application. And the multi-I/Os is also equipped with 2 USB ports, which provides a stereo input-output to any workstation as a PC, for example. So this is how you could interface with the analog and digital world. But of course, there's also some audio networking that we can offer. So let's take a small checkup of audio networking parts that we can use. So the first 2 inside this table is the gigabit port, which is called gigabit audio. We have the option of maximum 512 channels that we can transmit via fiber optical transmission. This part of module is like an optical interlink between 2 cores. So if you have a studio here and the MCR here, you could transmit the audio from the MCR to the studio and vice versa with this gigabit interlink. And you can transmit up to 512 channels via this physical fiber interlink. If you don't need as much channels, you could use also the APC interlink, where the interlink is the same, but you don't connect the gigabit ports with each other, but you connect the APC, 2 APC ports with each other. So APC on the MCR room, APC on the studio, for example, and when you make a connection with an Ethernet cable between both, and you have installed licenses in both of the cores, then you can make use of this APC audio interlink, where you can transmit 48 channels in both directions. If 48 is not enough, you can just place another additional interlink to double the amount. So if you have just 2 cables between those 2 devices, then you could have even 96 or even more channels that can be interlinked. Another optical interface that we can offer, I already mentioned it. We could have also a MADI interface inserted to the SFP slot of a core. So if you require MADI, so MADI is a very common format already, still inside many installations. Of course, we can interface with MADI as well. If 1 or 2 MADI ports is not enough, we also offer a concentrator, a specialized concentrator, which can take up to 8 MADI slots at one time. And also we provide some redundancy with MADI on the concentrator. So if you have redundant MADI coming in, you can do this as well with our cores and concentrators. And the second half of the complete table is about audio over IP. So we have also some interfaces into this world. One of the modules we can offer is the A67 Ravenna interface. It's ST2110 compliant, and also we can offer the ST2007 redundancy, so the hitless merge function. So the stream redundancy on both of the ports. We can support up to 128 input and output channels, so from the module into the DHD core and back. Here we have the audio over IP network, so which is A67 and Ravenna compliant. This is a real IP audio module. Here you have the option of standard switching, etc. So this is audio over IP, external audio over IP. Of course, as you might know, we also offer interfaces into the Audinate Dante world, so of audio over IP. So every of our cores, so XC2 and XC2 and XS2 cores are equipped with a Dante 4x4 Ultimo chip, which provides just directly inside the core an interface into a Dante network if you have one. And we support 4 channels in, 4 channels out. This is audio over IP. And if you have a larger audio over IP network based on Dante technology, then we can also offer a Dante IP audio interface with 64 by 64 channels based on the Brooklyn module. You already see that this module and this module look very similar from its outer shape. This is because these type of modules are inserted inside the core directly. Here's an extension slot where these type of modules, so A67 or Dante module, can be inserted. So here at this place or here at this place. The XD2 core has no own slot for type of this for such module type, but of course our concentrator can take also such module inside. So if you require A67 or Dante on a system which is based on an XD core, you just add a concentrator and add the module inside the concentrator. So this is the option you have at an XD core, of course. Yeah, so these were the first introductory words. At this part, I'd like to thank you also, and I want to inform you that we have already some videos online at YouTube in our channel. There was produced a news flash in fall 2020 to tell you about the newest developments. And we also have some feature videos about the Views app and some other features that we can offer. So to tell you that this is existing. And also we have produced some customer stories where the people tell you about the DHD consoles from the consumer perspective of view. So yeah, follow us on YouTube or Facebook, and of course follow my training right now. I will just do something. I have it already open, but I will show the initial process. So let's first of all start with the toolbox and some general settings that we can see inside the toolbox. So once you have the toolbox, you can use, we will provide this version 9.9.1.4. If you have another version 9.1, you can also use it. This is the most recent one. So yeah, if you have one. And you also can follow the training with another version of the toolbox if you have it. So it's not essential that you require this one, but it's the latest, and we will just provide it right now with the download link. Yeah, let's just start with the toolbox. So I just will double click on the toolbox application. And yeah, we just need to wait until it's opened up. So we'll see such interface, which will tell us that the toolbox is loaded. And afterwards, the application started. We will see this interface in here. So this is the standard view of a toolbox. And yeah, before we go deeply inside the toolbox and clear some wordings, I need to announce that there's a small application where you will be asked, if you start the toolbox the very first time on your PC, you will get a prompt that there will be an application installed, which is called DHDCS. And I need to tell you, share some information about this DHDCS, what it's about and why it should be installed as well with the toolbox together. When you go into the taskbar, the DHDCS is this application. So I will show it like this. What is the DHDCS about and why it's necessary to have it installed? Currently, all the systems, so this is our demo setup here, additional with some development stuff, however. And the DHDCS application is just for doing the communication between the PC on the one side and the DHD devices on the other side. Currently, the DHDCS is used for two main tasks. One of the tasks of the DHDCS is doing logging of the DHD devices. So if this is installed, you can set up log levels in order to produce a log file with the DHDCS. So this is the tool that you should install in installations in order to have a logging from the desk, in order to have actions on the desk recorded, or if there's a doubt of however what happens on the mixer, if there's a malfunction or some misconfiguration or whatever, this is the first step to do if you need some debugging, for example. So if I have a log level enabled in here, you will see when I just operate some faders on my demo desk aside me, you will see that there are actions logged inside the log file. So this is one part of the DHDCS. The other part of the DHDCS is doing maintenance with the devices. One part of the maintenance is done via the web interface. So when you click on one of the IP addresses, so I will do it for you right now, we will be redirected to our maintenance page of the system. So here we can see the firmware version, the uptime, which modules are installed. So this is more or less something we require in the support department. And if you ask us to get support, we will definitely ask you to show us something from the maintenance page, from the web page. So this is one part here, maintenance, but also with the DHDCS, we do some maintenance on the devices like network configuration. So this is the common this is the common way to configure a DHD device with IP address and hardware name. In the upcoming versions 9.2, which will be announced in the next year, we will have this more or less obsolete because the network configuration can then be also done via a new web app, which is called the system app. So the network configuration can then also happen inside the web page of the device, so via the web browser. So you don't require the network configuration from the DHDCS anymore if we have installed the 9.2 version. So we do this with the DHDCS. We can also enter licenses, which will be also in version 9.2 later on inside the system app. But currently, for compatibility with older devices, we require it also inside the DHDCS. So entering licenses is done in here. We can also save some default snapshots to the devices. We can also trigger firmware resets and system reboots from the DHDCS, or we can also do a factory test out of here. So if there's something required in order to test the surface of your desk, because you have a doubt if a button is really working well or if a fader is probably broken, you can do it with a factory test. If I enable it, the desk will go inside the factory test mode, where you can just test the touch displays, and you can test the faders, you can test any knob and every lamp of the device. So this is the factory test mode, which is very helpful in order to check if the surface is okay or not. Okay, so what we do also here inside the DHDCS is the logging. I already told it, so there are some logging options inside. It's installed with standard settings, so normally you don't need to care about it. The only thing you should specify is the log file directory. Choose a drive where you have enough space. Currently, we write files with maximum of 10 MB size. If the 10 MB size of a log file is full, we just start the new log file, but you can configure some cleaning option, so just to keep the log files from the last number of days. For complete logging, not to lose some log files, you just untick the box, so this is the standard way. There are also some logging filters, but normally we from the support department will tell our dealers or you as a customer if there should be something modified, if there's a special case that we should that we want to log. So this is some filter options in here. One important setting is the network preferences. So especially if you have a system with several network adapters, this could be important. When you don't see any device inside the DHDCS, it means that the DHDCS can't see the device inside the network. This is based on UDP. So normally, if you are connected to the same network, you should receive the messages from the from the DHD desk telling you that it's existing. But sometimes if you have several network adapters, it's worth to check the interface manually. So this, if you expect to see a DHD device and it doesn't appear, please check the preferences of the DHDCS. So we use this application just for communication, and the DHDCS is automatically started when you start any other DHD program, so like the Toolbox or the operations server. And so this automatically comes up. It should be initially started with admin rights in order to enable the DHDCS to register itself inside the Windows registry, but afterwards it should directly work for any of the users of the system. So now let's go into the Toolbox. Before the first break, I think we will just check some menus inside the Toolbox 9. So generally we talk about projects when we talk about the Toolbox. So a project is a file that includes everything about a special installation, about your installation. So for example, if you have 3 studios that are working with each other, this could be a project. Or if you have a broadcasting facility consisting of several frequencies, you could have a project for every frequency. So frequency number 1 is just consisting of a small MCR and 2 studios. You have a second frequency that is working, which is consisting of another project. It depends a bit how you set up the system and how the interaction should be. So a project is a combination of all the things that are working and interacting with each other. So it's a logical unit, and inside the project everything is stored which is relevant for operating the desks, and everything which is relevant for the complete installation. Of course, not all the installation, but everything which is about DHD. As in every project, as in every program, some of the things are pretty self-explaining. So you can choose a new project here, but the Toolbox always starts with a new project. You have the chance to open up project. You can save the project. You can save it with a several name. There are also some import and export options, but we won't touch this in this training because it's not relevant here. There's a nice thing which is called history. Every project has got a project history where you can yourself, as a system configurator, can enter some comments what you did inside the changes. So you can write your change log about the configuration directly yourself inside the project, so you did not lose it when you have another Excel table or whatever. Here, the change history or whatever you did can be written down in order to have this saved somewhere. So this is this tab. There's another menu which is called View. We will see this later inside the presentation when I show you the certain parts of the Toolbox. There are several things. First part is the maintenance. This will redirect you by pressing F7 or maintenance. This will redirect you directly to the DHDCS, where we already learned that this is used for doing maintenance. The other menus are logic sources, audio sources, potentiometer sources, and key functions. So all these 4 boxes we will see later on, because these are required to configure any mixer and system. So whenever we touch logic signals, we require the logic sources. When we touch audio signals, audio routing, etc., we will touch the audio sources. So these are the most common. When we configure something on the desk, we require the key functions. There's also some other things here which are not relevant currently. So if you are interested to get to know what about these points in here, we offer a Toolbox manual on our support page. The Toolbox support page is here, can be found here. I will just show it that we have support.dhd.audio. So here we have listed everything current for our software, firmware, and bundles. So we have some manual for the Toolbox, for example. You will find everything about the Toolbox. So if you have something not explained or which not explains itself, you can take a look into the manual, of course. The transfer load to device, load from device. This is the very important thing, so we will use it a lot during the training, because this is the part where we can transmit the configuration into the mixer. So where the configuration is transmitted to the device, so to the XC core, for example. And yeah, so if there's a load button, this also intends a bit that the toolbox configuration is a complete process that you can do offline. So you don't require the hardware at your side when you do a configuration. You can do it on your system, onto your laptop or workstation at home, and do the configuration, do some preparation, and afterwards you go to the desk and send in the configuration. But you can do everything that we show here, even without the mixer aside. Of course, you cannot check what you did, but you can do some preparations as well, just offline, without having any hardware available. So transfer process we will see later on. There are also some additional options inside the configuration. I will just tell you about the most important. This is the toolbox configuration files. Here is some autosave option that I've added to my system, because you can choose to autosave a project file to a recovery file, for example. This is very helpful if you make changes inside your project and you forgot to save those. Of course, you get prompted if you have did changes, but however, maybe you want to go back to something else, or maybe the system crashed or whatever. The recovery file will be done in the amount of time that is written down in here. And the recovery file is always there. And if you open up the same project again, the toolbox will see that there's probably a newer recovery file than the project file you already opened. And the toolbox will prompt you if you want to use the current project file that you opened, or if you want to have the latest state that is available in the recovery file. So it's pretty helpful to do this. You just specify the path for the backup directory and where the recovery file should be stored, and then you're done. So this is pretty helpful if you want to have a certain backup generated all the time. Two other helpful things. This is this one here: views, delete all custom view settings, column layouts, etc. This is about these windows here. Currently they are not filled because I did not configure any mixer inside here, but as most of us are working as technicians, maybe we have a workspace where we have two displays, and sometimes we work on two displays, and I can just drag some windows on the second monitor. And if you go with a laptop somewhere to the other destination, I just have my laptop single screen, and sometimes I miss these logic windows, and if they are lost, they are still there. We are pretty sure, but they are just located on the second screen, which is currently not available. So it's pretty hard to get them back without a second screen in this case, but therefore we have this option view, reset views, and this will bring you back these views to the standard positions. When you press this one here, it will reset the views to the custom settings, and you just need to restart the toolbox to apply the new settings, and then the windows will be back for you. If you should have problems when you make configuration for the views, for the view design, and you should expect, or you should see that the TFT view designer inside the toolbox is not showing something, just a black screen. It may be that your GPU cannot handle some things, so it makes sense just to try out the use software rendering. In this case, all the TFT view preview rendering will be done in the CPU instead of having it done in the GPU. So this is just a fallback issue. But honestly, we did not have any more issues on TFT rendering in the past time. So this is just as an information that it's existing. All the other things we don't need to touch. Currently it's set up to standard values, and we should be able to configure the mixer in the next session, after we cleared up how we construct projects. So from my point of view, I will just make a small break, and afterwards we will just talk about the general wordings in the Toolbox project. So we will talk about project, devices, and the mixer. Yeah, hello everybody. For the second part of the first training today, so the second of 6 parts of Toolbox Basic Training. We ended up in the last part with initial toolbox things, but now we directly get into a project. So we start up setting up a mixer here. So so many of the important things, so here's the mouse, starts with a project. So what is a project? First of all, some introductory words, and then I will make a drawing for you in order to make this more clear. A project is everything which is working together, which is a unity inside the installation, for example. So here the project could be training, but it could be anything. And excuse me. There are 2 important things for the project. First of all, you can give it a project title, and here's the project ID. We will later learn what the project ID is about. And everything which we have inside the project, here are some global settings. So all the global settings are common for everything which is inside the project. So there are some general settings for the project. So this is common for all the devices that we will add later. We have some font settings. This is becoming important when we create views. There are also colors that we can use, where you have user-defined colors later on. So this is a general project setting. There's also some tagging option, which is defined in here. You can make some colorization inside the configuration in order to make some tags to make a bit more obvious what is going on in the mixer. We'll touch this later on. And there are some resource files. We will definitely see the resource files later. This is about adding PNG pictures inside a TFT, a view surface, for example, and also about UTF-8 character sets, but we'll definitely touch this later. There are also some global controls, so like resources, so for lines or antenna resources or whatever. So there's an included resource system that you can use if you require it. There's also something about global labels. So and the most important part in the global control is probably the administration. So you can add administration groups and also user accounts in order to make things protected on the mixer. So you can protect keys and DSP functions just by adding user accounts. And even for the upcoming version 9.2, it's more important to have user accounts with administrator settings, for example. So this is a global setting. So everything that you configure inside the global scope here, so is true for all the mixers that you have inside the project. So this is the global tab, the global things, the project part. By right-clicking or pressing the add button here, you can add devices. So this is the second term. So we have the project, and then we have a collection of devices which making our project up. So we can add XC cores, we can add XD cores. We can also add some basic configurations that we have prepared for you in order to get a good starting point. So you don't require to start from scratch with a project. You either have already an existing project that you can use for configuration, or if you buy a console like this one here, like an RX2, in this sample here, you can use the RX2 basic configuration as a starting point, RX2 base config. We will take a look into this later on. There's also a small sample configuration for the TX, and we also have some standard configuration for the SX2. So there are already starting points that you can use for taking a look into the config and as a starting point for your configuration that you just need to modify. But of course, you need first of all to understand how the complete system is constructed in order to get along with something like a sample configuration. So we can add different devices in our project, and a device is a core, for example, and this is where I just start the drawing right now. I will just turn on my draw pad and just let's take a look at the drawing. I will just make some devices inside here. Maybe this is an XC2 core which we call Studio 1. We make another XC core here, or S2 core, which we call Studio 2, Studio 1, and maybe we have in a small project, we have a device with an XD2 core, which is the MCR. So this could be a project. So a project is the combination of all the devices that I have together. So this is a device, this is a device, and this is a device. And every device inside the toolbox, this is here, and then every device inside the toolbox has got its own options. So every XS or XD or XC core is a device. And this device has got its own options, its own configuration with its own IOs, its own mixers, and its own audio system. So every device is a standalone device. But we return to the drawing. Every of these devices then can have got mixers connected. So I just make it like this. The XS core, for example, has a surface, a console, and IOs. And the Studio 1 also, of course, has got a console and IOs. And the MCR probably only has got IOs because it's just a router, but no console. And each of these devices has its own configuration, and we will talk about today how to configure such a device like the Studio 1, like this one here. We will talk about this one. And when we are talking about a project, it does mean that a project is the combination of everything together, like this one here. So this is the project. And within the scope of the project, it is possible to have some interaction between the devices. We won't care about the interaction, but this is the nice thing within the project. The devices can interact with each other with exchanging logics with each other. So if a switch at Studio 2, for example, is switched on, some red light, etc., we can get to know this directly in the MCR. And this is just using an integrated way of communication to exchange the logics with each other. So you don't need to care about how to get the logics from one core to the other. It's just an integrated way. Of course, this is one part. You have the logics in here. Of course, as we already learned, we can also have some audio transmitted between the devices as well. So audio could be also here. Audio. Sorry for my handwriting. I'm a bit quick, but I always say my handwriting is already encrypted sometimes. Okay, so this is the drawing we have. So we will talk about the project for now, and then we already understood what the project is about. But now let's go into the studio configuration. So let's make a Studio 1 configuration with the console and IOs. Here we are. So I will just place it aside. So everything which is specific about the device is done in the device tab. So we already see that there's a hierarchy of the configuration. So it's pretty clear from the structure inside the project tree that that this is the global part, and this is now a single part which stands on its own. So as I said in my drawing, we will make a Studio 1 like here. Studio 1, this could be the Studio 2. And this could be Studio 3. And now everything that we will learn, MCR we have here. And everything that we will learn will be inside this device tree. So this is common for all the devices. So when you open up the node here, everything that we have underneath the device, it's common. So when we learn this in the first device, this is pretty okay. Here we see the device number. Why is this there? Of course, when we talk about interaction, I will just return to my drawing. When we talk about interaction, of devices, there need to be a system in order to mark devices that are interacting with each other, and to prevent that other devices from other projects don't interact with each other. So here in this case, every device inside the project has got an own number. So for example, in our system, this has got the 64, this has got the, this is the 65, and this is number 66. And all the devices have a unique number within the project, and the project has got its project ID. And all the devices that belong to the same project ID can interact with each other, while other devices with a different project ID cannot interfere with this system. So the project ID is like a unique key to mark devices that are interacting. So you can even place several projects inside the single same network, but with the project ID, all the devices know which are the friends and which are not the friends. So every device inside the project will only talk to the others from the project, but not with other projects. So this is pretty safe. Yeah, so what we do configure inside the device. We have a device name here. The device number we cannot change because inside the project the device number needs to be unique in order to prevent interferences between same device numbers. So this is very necessary, and this is just for information purposes here. At the Options tab for this single device, we find some checkboxes here which are pretty important because there are several options that you can use, but which are not necessary in one or in some cases. So for example, I just will fill this with some information about the licensing. This control networking license here, the tick box with the send control logic information, is about that you want to use this device to interact with other devices inside the project. So commonly the license is not on the device, so only XD cores are equipped standard with this license. So if you require some interaction with devices inside the project, you require the license and to tick these boxes. But sometimes you have also projects that don't require interactions with other devices, so this is not necessary. So you only need to buy what you really want or really need inside this project scope. Another thing is the audio networking license. When you check this box, you are able to configure the APC interlink I talked about. So this is the Ethernet cable that you can just place between APC ports of two cores. If you want to make use of it, every of the devices needs a APC audio networking license. So if this and this core has got this license, you can place the cable in between in order to transmit audio between both cores. If the checkbox is not ticked, you cannot configure this. Additionally, we have some enhanced DSP processing, so there are some special bus options and special processings that you can only use if this box is ticked. We will see this later on. There's another feature which is called Control Link. Please check out our feature videos because Control Link is presented in there. What you can do without it, it's in short words, it's a remote control option where you can control, where you can take or say that a part of the mixer, like a fader module or a center module, should connect to a complete other device somewhere else in order to take over this configuration, in order to remote operate another mixer with your hardware here. It makes probably sense for OB vans where you remote control the playout system, for example, or in other applications. So check out the feature video for this one and the documentation as well for the controlling feature. The shared channels option is also a license feature that you can make use of it. Normally in the mixing desk, I will just switch over to the mixer again. In the mixing desk, any of the signals that we have here, like microphone 1, 2, and 3, , 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, more often on the mixer. So if you have the microphone 1, it's just on this fader or on another fader, but it cannot be on other faders at the same time. With a shared channel license, you can enable that you can place signals like microphone 1 or whatever channel here onto other faders as well, in order to operate them in parallel from different console parts. Why do we have these licensing boxes? This is just for let's say some security for the person who configures the project. If you the toolbox will prepare everything for making the system work, and as the configurator needs to decide what to configure and how to make the system work, we wanted to prevent that you configure things that you probably don't have available. So you need to decide if you really require the audio networking, because if you start configuring something and then you try to apply the config and you just get to know, oh, this won't work because I don't have any license available, this is a very mad thing. So some things definitely need to be enabled first of all before configuration in order to make use of it. So this needs to be a very you need to manually do it, because you can decide if you require it or not. Some general settings for the device are about virtual mixers. So we won't touch virtual mixers at all, but just a small information about virtual mixers. When we have a device, I just will make another drawing here. When talking about a virtual mixer, we could have, take black. We have the core here, XE2 core, and in my first example, we could see that it has got some console. But it is possible to equip an XE2 core with several mixers, which is called virtual mixer. Mixer 1, and it can have another mixer. Mixer 2, and it can have also up to 4 mixers. And each of the mixers is able to have its own console and its own bus system and its own n-1s, etc. So this is about virtual mixers. In this place, you can add more of those virtual mixers. We will talk only about the configuration of one single mixer, because if you understood this one, you can also understand how you configure virtual mixers. There are also some additional settings about snapshots. So this is something we can keep away for now. We have some special settings we will touch when we talk about I/O configuration. There's a general level adjustment setting, and we will talk about level adjustment very soon, what it does mean. And then there is a tab about the web apps. So we have currently in version 9.1 already a lot of web applications that you can use. So and when I say can use, it means that you can, in the configuration per device, you can decide if some of the apps are available or not. So if you want to make use of the Views app, you of course require the license. This is why we have this small information here. And if you don't want to have enabled this, you can untick the box. This is the same for the Snapshots app. So we can operate the snapshots, we can modify, rename, save, make backups from the snapshots with the Snapshot app directly with the web browser. There's also the so-called Labels app. So with the Labels app, you can modify channel labels directly with the web browser, or even global labels can be modified with the Labels app. Additionally, we offer some REST API interface, which needs to be licensed as well. So for external systems that want to make some changes like loading snapshots, changing labels, etc., this is all possible with the REST API. And this is done all in the Web Apps tab. So if you need any option inside the web interface, here's the part where you can configure who's able to see which view, who has which rights. So this is the part where you do everything which is from the device provided inside its web page. And generally, for the studio, for the device in here, we have some view clock format settings. I think this is pretty interesting for other countries, because you might have another date format, some other date structure, some other clock format like the 12 AM PM format. And you could have also some other weekday abbreviations. So here is a central part where you can modify the clock settings. Of course, when we talk about views, we will see the clock setting as well, but here we have it. So we already talked about the project scope. Now we have the device scope. And within the device, we have several options that describe this device in its inner settings. We have, on one hand, we have the hardware settings. So we will touch this in a few minutes. The hardware just describes which type of core I have and which APC ports are configured in which way. So here, the hardware tab we will come to. The I/O overview. This is the point where we configure the audio interfaces. So in the first part of the presentation, I showed you the examples of I/O modules that we can have. And here is the part where you configure these I/O interfaces. So every input, every output, you must first of all design and add your I/O interfaces here. So like a digital interface, probably a HIC headphone module. You can add Dante interfaces or even a MADI module, some channels. So this is a very initial process that you need to do, because somehow your system needs to be described at a first time. So when you start with a project and you start to configure a studio, you definitely know which inputs and outputs you require, if you require GPIOs, and how the signals should work. So you probably also know how the outputs should be configured, which signals you require on a certain output. And this is a first starting point for the configuration. This is the definition of the inputs and outputs of your system. So when we want to make a mixer, of course, we require inputs and outputs. So the core we have already, the inputs and outputs need to be attached. And in a third step, we require the surface. And the surface is located inside the mixer tab. So everything which describes the mixer, so the surface and all the functions about buses, etc., is located inside the mixer tab. So the mixer describes which buses we do have, how the PFL bus is working, if there is some special authorization on certain DSP functions, how the mixer is working in its own. So this is unique for the mixer. And if you would have a virtual mixer, I just showed this in the studio too. If we would have a virtual mixer, we would see that we have a second mixer tab here with a virtual mixer. And this virtual mixer has its own setting about buses, etc. So even if we are using the same device, the same hardware, so we have the same DSP processor for both mixers, each mixer is unique in its own configuration. So the user of these virtual mixers won't see that they are operating on the same device, on the same core. So this is like a virtual division of the hardware that we have into several mixers. Let's go back to our Studio One core. So here within the mixer tab, we have everything which is about the mixer, the mixing desk itself. So this is why we also have some console configurations. So we will touch this definitely later, because we want to prepare a mixing desk on our own. And we also will talk about all the other things that are required for having a mixer configured. The audio part here of the device is a unique part of the device itself. The audio part includes some specialized functions we will see in the second half of the training. We will talk about output functions mainly, so we will learn about the super output functions. And this is more or less about the audio system, so about monitoring and specialized mixing functions that we can use to provide any of special audio signals that we require. So this is inside the audio system. And aside the audio system, of course, we have also a logic system. Our logic system, what is a logic? A logic can be something from an I/O box. A logic can be a GPI. A logic is also used when I want to configure a GPO. So there's something inside our system which is called a logic, which can have a state true or false. So here inside the logic system, we can do things about logics. So creating new logic states with so-called logic functions. There can be level detects. We will definitely learn what those do. We can have logic delays in order to have some specialized logics. And yeah, this is the most, excuse me. So this is the most important things we have inside our mixer. This is the logic functions. You will definitely have this installed in your configuration because they are very powerful, and every special state you require and need to make in order to have some certain information is done with those logic functions. So as important parts, we already have the mixer and its console, because here we describe the mixing desk. We have the audio part, because here we do all the nice stuff, which is about monitoring certain signals that we need to send out to the outputs of the console. Here we have some certain logic functions in order to create new logic signals that we require. So any specialized things we will do here in order to have it as a logic. And here we have another third important part about our configuration, because when we take a look at the mixing desk, we will see that we have some hardware, but a lot of is about TFT views or views at a glance. So that also can be used in the web, of course. But yeah, these views also need to be configured, and I will give a glimpse and a touch on the things that you can see and configure in the views. So this is the points that we definitely need to touch. But let's first come to the audio system. We already showed the IOs in here. But before we start to configure a mixer, a real mixer within the Toolbox system, I'd like to show you. So here we are. Before we start configuring a mixer within the Toolbox configuration, I'd like to show you the systems drawing, so the internal signal flow of the DHD mixer. So what is the general signal flow of the device? Now, when I show you this drawing, you will say, "Oh, this is very complex and very big." Of course, I will just touch the most important part of this drawing, but it's important to understand how the mixer is working. Of course, if you want to see this drawing on your own, and if you want to take your time to understand this drawing, it's no problem. We have this drawing available on our support portal as well. So if you navigate to support.dhd.audio, navigate to Install and Maintain, and click to Overview, and you need to scroll down a bit. Then you will see a section which is called Audio and DSP System. And here you have some certain information about the block diagram of the audio system. When we open up this, then you definitely get this drawing that I will explain to you right now. There's also some specialized information about the signal delays that you will expect inside the DHD system. So what is the latency between a microphone input, for example, when it's transmitted via APC inside the core? You do some processing and you will hear the signal back on the headphones. So what is the typical system delay? It's 1.1 milliseconds, so not a long time. And even if you don't use any processing, it's quicker. It's 0.3 milliseconds, for example. So if you want to learn how huge the delay from input to output is, and if you want to have an estimation, you can take a look into this delay document here. So now let's go to the block diagram of the audio system. Before we zoom in, we have a green dotted line here. And everything which is within this green dotted line, this is inside the DSP, inside the routing and inside the DSP processor. Everything we have outside this line is outboard equipment, outboard as in the meaning that we have I/O modules in here. So here we find all the I/O modules I already showed you, so the mic line box or the output box on the other side. So these are the I/O modules which are connected via APC to the system. So let's zoom in and let's take a first glimpse inside our system diagram. You will see that there are such red boxes inside the drawing. These boxes show signal tips and signals that we have available inside our configuration software in order to use them. At all, it does mean that everything that is marked with red here appears as an audio source inside the toolbox. So just switch to the toolbox. When we open up our audio tree by double-clicking on an audio source or opening up the audio sources with F6, you will get this audio box, and within the box you will get a list of all the available signals that are there in the system. And everything which is marked with the red box inside the signal flow drawing is a signal that could appear inside this list. So what does happen when we connect a signal to the system, and how is the signal flow? Let's make an example with mono microphone input. Here we have a microphone box. Inside this microphone I/O box, first of all, we have the 48-volt switch. We have some analog gain stage. Afterwards, we will convert the signal into the digital domain with the AD converter. And afterwards, we will make a fixed number to float number conversion in the digital domain. Because inside the mixer, we don't work with fixed numberings, we work with floating point processing. This does mean that we have inside the mixer a very high headroom, so we can mix up signals without any clipping or whatever, because we have a headroom about 700 dB, so you can even stack signals above each other with high levels and you won't get the mixer clipping inside the system. So the clipping, if there's clipping occurring, it does occur on the conversion back to the outer system. So when you convert the internal signals back to a stereo analog output, for example, or a digital output. So at this point, so when we go back to the outside system, we need to take care about the internal signal levels, that you don't override and overdrive the outputs. Let's return back to the input. Afterwards, the fixed to float conversion for the internal processing, there's another level adjustment, which we call headroom in here. And we will talk about this level adjustment pretty soon, what it does mean and where you should use it for. And after this level adjustment, we have first signal tip here, which is called audio sources input. So this is the signal we use inside the toolbox from these inputs, so which is listed here with input. So this is the signal we get from the input. Afterwards, so in a mixer, like we will configure right now, you will have the signal probably put on a fader. And when we have fader processing, the following stages take place. Whenever a signal is on a fader, we definitely have available digital gain, plus minus 20 dB. There can be a phase switch, so if you enable this, the signal will be phase inverted. And afterwards, we have here in the drawing a processing chain example. So here in the drawing, we have subsonic, 4-band, EQ, compressor, and limiter configured. But you can define your own what the processing should be in the fader. So if you want to have a de-esser, it can be inserted as well in here, or a AGC or whatever. This can be configured in your system, so by yourself. So we have only an example here. Also, the order of the plugins in here can be different from this example. After we did the processing, there's another signal type we provide inside the configuration, which is the audio source pre-fader. So if you want to have the pre-fader signal somewhere routed to an output, or to make something special with the pre-fader signal, this is the source after the processing and the input stages here. You also see that we offer some inserting here. So if inserting required, we have switchable inserts that can be used, or even you could insert at a certain point other signals directly to the fader. But in most of the times inside a broadcasting desk for a self-operator or something, you won't require inserts. But it's there, it's happening at this point here. After the pre-fader, of course, we will end up somewhere in the fader itself to go to the program bus. But before we go to the program bus, there is a panning stage. So panning does mean where the signal is located in my stereo mix. Is it on the left side or on the right side? When we work with 5.1, which is also an option, we can also decide if the signal is placed to the rear speakers, if it's somewhere in the middle, if it's a mono signal. So these options are all done by the panning matrix in here. If we have a stereo bus, we have also only a left and right pan, or if you have a stereo signal, it will be a balance option in here. So this is taking place in here. Because of the 5.1 support, this panning is looking pretty complex, but yeah, it's necessary in here. When the signal is ready, after the panning, we have the fader coming in. So here the fading does happen, and we see a signal rooted in here. This signal is here the pre-fader signal before the fader to provide some signal for the aux buses. So we have 3 different bus types that we can provide. We have aux buses, we have normal program buses, which is the stereo buses. We have PFL buses, second signal type, so they take place as a pre-fader signal, or if the option is enabled, we have also the PFL bus like an AFL bus. So both options are possible. And at third, we have aux buses. So like a classical aux bus from any desk that you already know. So for monitor mixes or N-X you can produce with the aux buses. So this is with the aux bus. Every aux bus has a pre and post fader switch, and also every aux bus has its own send level. So the signal inside the aux bus has its own send level, so like you know it from aux buses. If you make use of the automix, which is also an option that you can use. Currently it's disabled in standard configurations, but you can enable the automix in order to level signals on the desk automatically, like microphones from a guest table, or the general mix can be automixed. If this is enabled, here we have inserted the information how the automix is integrated, so it's working like an attenuator after the fader, because the automix is not doing some gain on signals. It's just attenuating signals which are not so important or are evaluated as not as important as other signals. So the attenuator from the automix is taking place right after the fader, and the measurement point for the automix, so there needs to be some evaluation from the current signals. This is taking place and marked with these red nodes, and when we follow the line, here we see just some information how the automix is set up. So there's some weight leveling, so this is all the measurement only. So we see that we have 3 different automix groups. So if you work with automix, this is taking place in here. We go upwards. So we already talked about the buses. So all the buses we have in this routing here. So yeah, we have the buses. You can have even more buses, so up to 48 buses can be constructed, but just to have an example, we have just only 2 aux and 2 stereo buses in this drawing. Every bus, when we have it here, here's the program bus number 1, program bus 2, so this is the signal we have here. Every bus can be equipped with an internal limiter, so this is just an option that you can enable inside the toolbox configuration, so you don't need to make a separate limiter for every bus. There's also an internal limiter already for each bus. Yeah, afterwards the bus, so we have here the audio sources mixing. So here are the signals that come from the mixing buses, like aux buses, PFL, etc. Another option we can have is the so-called fixed processing. So this is a certain part of processing that you can add to the system. So it's an option that you can make use of if you, for example, require some certain processing for the program bus before you put it onto the antenna. You can do it also with our desk. So you could have a certain EQ, compressor, limiter, some delay or whatever, which is also available as a fixed processing DSP function. And so you could route the signal from the program bus also directly through fixed processing, and when the fixed processing is processed, we have also audio sources from the fixed processing, yeah, providing the processed signal Before we go to the output, let's just check what else signals we provide here. We have also audio sources mixing functions, monitor functions. So this is all about monitoring. I will show this later on in the second half of the training, how we configure monitoring. And also we will show about the output functions. So what the case is about here and how to configure this. So these are also audio sources we provide inside our system. So when everything is ready, somewhen we send the signal again back to the output. And what has happened at the output stage, before the out is converted to either an analog output or sent to a digital output, there's again taking place a level adjustment here. And then we do the float to fixed conversion, because we are working floating internally. And afterwards, we will have the digital analog converter if it's an analog module, or we will just convert this internal signal to AS3 or MADI or whatever. So this is what we do on the output side. Yeah, so this is the signal flow in rough. The other colored boxes inside this inside this drawing just show other input examples. So how is a stereo input handled? How we can go around with 5.1 inputs, which is also an option if you have a surround system. The most common cases will definitely be mono to stereo buses, or you have a stereo input to stereo as well. So yeah, we have shown everything here inside this drawing. So I already see, excuse me, that the time is nearly over. So I will just show the time for the second part is over. Yeah, I will show you right now some settings. We will start just a bit with the I/O modules. So some general things we already can do before the break. So when you have a definition of your system, you just need to add the I/O modules that you have inside your system. And you can, very common settings are here that you can give it a name, A3, or let's say digital I/O. You can give every I/O box its name. And big headphone and MADI, we can give it a name. Every of the inputs and outputs can have its own naming. So this is not important for the mixing desks, but in your configuration, of course, you need to know which signals are connected to this I/O module, for example. So let's make an example. We could have a codec connected to this digital input, or some CD player. Let's make probably another analog module like this one, analog I/O. Like this one here, we could connect, let's say, some telephone in an analog way. We could have probably also CD player, but analog. Whatever is existing in your studio, you would name the sources, and also you would name the destinations. So here we could have, in the digital output, we could have the PGM out, or whatever. Or you would have the N-1 for the codec. And this is just some labeling that you know what should be there. So when you make the input names, you know which signals are behind this connection. And when you make the output labels, you definitely know which signal should be available here. We have this I/O overview structured also in a tree. So if you press on all units, you get a list of all inputs and outputs, as well as GPIOs. So when you want to have all the signals at a glance, you can make use of this list. There's also some filter buttons. You could say you want to see the inputs, but only audio inputs. You could also see you would only want to see the logic inputs, so the GPIs in your system. Or you want to only see the GPOs or the audio's outputs. This is pretty helpful if you are searching for signals. And by the way, searching for signals, when you have your focus inside one of the boxes here, you can just type in with your keyboard to search for a certain signal. When I type in CD, I will get the list filtered by everything which has the tag CD inside its name. Or if I write n-1 as a signal name, you would see all the signals. Without searching the signal manually inside the list, you can use the type-in filter. So this is one general thing you could do about the inputs and outputs. You would enter cable numbers or whatever, and as a small helping tool, there's also some multi-select and multi-rename. It's pretty simple. You just mark the inputs that you want to have numbered through. MADI out 1, 2, 3, 4 up to 32. So this is what you can do with the naming. There's also some other things. When you enter a name and you press enter, the box will tick the next one in order to enter names. This is like a batch label entering. Okay, so for now, we already saw something about the I/O configuration, but the most important parts about I/O configuration will be shown in the next session, in the third session of the first training part today. So see you in 15 minutes. We will start again at 10:30. See you, take a break, take a coffee. See you later. See you, bye. Yeah, hello everybody to the third part of the first part of the training. So 3 of 6 is the part of the training right now. So we ended up in configuring the inputs and outputs of our mixing desk. And I wanted to show you some settings of the I/Os that are very common for inputs and outputs. So we already saw when we looked at the inputs, like for example the digital input here, that there are some settings that are common for every input. So we have labels for inputs and outputs, and we will see one box which is there for every input and output, which is called the level adjustment. And I want to share some information with you about this level adjustment and for which option this is for. In the signal flow, we already saw that the inputs and outputs have such level adjustment tag. So I mean this one in here. So level adjustment like this one here. And why is this there? I will just switch to my sketchpad, and I just thought that it's good with a drawing to explain what it does mean. So when we have the DHD core, this is the internal audio system, and it's now about leveling, so the internal levels that we use. So we working floating point inside, and of course we need to have some internal signal reference level that we use for our operations inside. And we do this on the basis of a signal level that we call dBint. dBint. This is the internal reference level for our mixing desk. So everything that we do references to this level. But of course, in the outer world, with analog and digital I/O modules, there are other reference levels available. And these reference levels even are different for other installations. So in your facility, there might be a special reference level for analog signals, for example, or for digital signals. In other installations in another country or whatever, the conventions might be completely different for analog and digital reference levels. So what to do about it? So I make a small drawing for an analog I/O. Analog, for example, with dBu, or the digital signals with dBFS. So this is the scale we have in the outer world. And of course, we want to have signals from the analog and the digital domain inside our DHD mixer. And we want to have it also back in the analog or digital world as an output. So we either need a conversion from the analog level convention, so from dBu into dB internal, for example, and we also want to have some setting for aligning the dBFS, the full scale level, into dB internally. So we need to normalize our system input and output sides to reference with the broadcast enables we use in our facility. And this is done And I switch back to the toolbox right now. And this is done with the level adjustment here. For example, we start with a digital domain. We have a CD player here, for example, and a codec. And we could say that the level reference for digital signals in our broadcasting facility is -9 dBFS. So we could say the level adjustment, which is the standard in here, which is pretty common as a digital reference level, that the internal that a signal with a level from 9 dBFS full scale is referenced to 0 dB internal in our DHD mixer. So this is the common level for digital signals. If my broadcasting facility has got other headroom settings, like let's say -18 dBFS is the reference level for digital signals, then we could say that set this setting to -18 dBFS to 0 dB internally. So when I place a signal with 18 dBFS minus to this input, we will see a level on a level meter, for example, in the DHD core with 0 dB internally. So this is a signal level alignment to an internal reference with 0 dB. The same we find for outputs, like on the digital output. Here we tell again a level with internal 0 dB internally will generate a level on the digital output of -9 dBFS at this point. When we change the setting to something else, for example like -18 dBFS, then the internal level with 0 dB internally, for example from a tone generator or whatever, will produce, so every signal with 0 dB internal level will produce at this output a reference level of -18 dBFS. So this is the alignment that I can take in place for referencing my broadcast levels to my DHD mixing desk, input side and output side. If these settings are common for the complete mixing desk, I can return to the studio settings, to the device settings, and there's the level adjustment tab. And the level adjustment tab, with this setting here, I can bring all the digital I/O levels to the same match. So if I could set this to 0 dB internal or -13 dBFS, if I do this setting here, all my digital I/Os will use this setting. So I have it it's symmetric for the inputs and outputs after applying this setting. Of course, in my drawing I also had the analog domain, so let's just make a small checkup on an analog input. And here we have, for example, the CD player analog signal. And here we have 2 steps of level adjustment, which is just for completeness. But the most important part is the dBu part here and the dB internal part. So which external level in dBu matches the 0 dB internal? This is the question we answer with this with this drop-down box. So current setting is 6 dBu will produce a level of 0 dB internal inside the mixing desk. The same we have at the output, so a level of 0 dB internally will make a level of 6 dBu at this analog output. Of course, here again you can set this to levels that apply to your facility. So if you would have another reference that 0 dB should be the reference level for all the signals, then you can set this up for every single I/O, or you can even use the central setting I already showed at the device level here. What are the common tasks of this? So normally you have a reference level, but you could accomplish something else with this setting. 2 common examples are, for example, if you have outboard equipment, like let's take this CD player. There are some external equipment that has a very high output level. And of course, we should match this somehow inside our mixing desk. So maybe there's equipment which is not using the common levels we use in our facility. And let's now assume that the CD player would produce an output level of 15 dBu with a reference tone. And of course, we want to map this to 0 dB internal. And when we assume this right now, we could set this input, this certain input, to a special setting and say the CD player 15 dBu match 0 dB internally. So I can map even other different input levels to 0 dB internally by just this setting. Other example for outputs, very common question is that some of the presenters say that the headphone output is too dim. It's not loud enough. And without changing anything inside the audio system with higher levels, you can accomplish this task if the headphones are a bit dim or whatever. You can set this with level adjustment. You can say, okay, if the headphone is, this specific headphone output is too dim, you can raise the level by just changing the level adjustment in here. So if it's too dim with 6 dBu, you could say 0 dB internally now produce a level of 12 dBu at the output. So we just raise the output level by 6 dB by just changing the level adjustment. And the only thing we need to do is sending the configuration, and afterwards the setting is applied. Yeah, other settings are also provided in the input-output stuff in here. So digital inputs also come with sample rate converters and special mode settings. So this now is on YouTube, place the appropriate settings, especially for the digital IOs. But this is one thing that you need to do when you set up the desk in the end, and then the settings are done. Okay, so now we already learned how we get IOs configured. When we have the task to produce a mixing desk, we already have some of the credentials we need. So we have the DSP core already. So we have the Studio One core. We have already IOs. But now the question is how we get the surface and how we get the buses. So our example that we're producing here in the training should show us how we make the mixing desk work. So how we get the signal onto a fader and how we get the signal out of the system again. And so now we change over to the mixer settings in here. So what do we need to do for steps to configure the mixing desk? When we take a look at our mixing desk here, it's very obvious that we have faders in here. So we need to produce something with faders. As an initial thing, I did not do already, I will send in the configuration that we have already produced. So it's nothing very important inside. But I will show you what will happen when we send in the configuration. So I just clicked. So I just want to apply the configuration we already have. So we have the Studio One config, and I will now first of all transmit this configuration to what I have as a core here. So this is my training device. So this is an XC2 core, and I will just send in the configuration. Now we get some information, so we get a confirmation to read. So I will just explain what it does mean. It's written here, to apply the new configuration, the audio system must be reloaded. Continue. We always get prompted in version 9.1 or since version 9.1 if there are changes that will force a reload of the DSP. In former versions, it was always the case that we always reloaded the DSP, but there are some combinations of configuration where you made probably only changes of labels or did some redesign of the views, which is not making it necessary to reload the audio system. So we built in some special system in order to detect if it's necessary to reload the DSP. And if this is necessary, you get prompted that you know if you apply the configuration to the core that the audio system will be reloaded, which will cause a small audio glitch in the system. Maybe the faders are completely reassigned with something else. And yeah, so this is just a prompt to let you know that the system will be, audio system will also be reloaded. Of course, we want to proceed. This is why I click yes. We get another confirmation, and this confirmation is pretty important because if you see this confirmation, which is letting us know that the project ID in my Toolbox project is currently different from the project ID which is in the device. So we have different project IDs. This prompt is pretty important because if you have the project opened and you send in, I just click no, and you just by default selected the wrong device from the list in here, and you want to proceed with sending in the configuration, this should let you think if you probably selected the wrong device from the list. This message is existing either if the project ID from the device that you want to send the config in is different, or if there's a mismatch of the device ID. So this prompts letting you know that the project ID or either the device ID is different should let you think if you really want to proceed, you should ensure that you selected the correct device. In my setup here, it's correct because I want to reset the mixer to something we are configuring right now. If I send yes, the config is transmitted to the core. If you check the surface, we already see it's looking very unconfigured. So this is because I did not do anything inside the configuration for now. And we want to change this. We want to make use of the faders. We want to apply some configuration for the faders. Initially, as we did a very rough change of the configuration in my system right now, so this is completely different from what has been installed before, I will do something inside the DHDCS because I want to make a firmware reset of the system. I do this because our core has got internal a small memory which we call parameter memory. And the parameter memory is there in order to save the current state of the mixer, so which faders are opened, which logics are on, which sources are on the desk, and this parameter memory is valid for the current configuration. If I change the configuration in a way like I did it right now, so I made a complete different configuration for the mixer, of course this parameter memory is not valid anymore. And with making the firmware reset, the parameter memory is invalidated and deleted, and therefore I start up after firmware reset with a new parameter memory which has got no information anymore about the old mixer which has been installed before. And so if you make some tries with your demo system or whatever, a firmware reset is a good choice when you make rough changes of the config. So now we applied the configuration, the mixing desk is very blank, and yeah, we will now see how we configure the mixer. We go to the mixer tab, to the mixer node, and now we want to configure the buses and the faders in order to make audio signals to produce the mixer, to have the mixing desk working. In the mixer itself, we have some common tabs again. The most important tab here is the mixing functions, because this is the point where you add program buses. So remember the signal flow, there had been some buses already, and in a standard configuration when you add a device, we always have 3 buses already there. We always add a PFL bus as a standard. So for monitoring, for PFL, for signals, sometimes it's also called Q. And we have 2 program buses. So program bus 1 and program bus 2. Of course, you can add even more program buses. You can also add, if the core type is correct, excuse me, you can even add another PFL bus. You could add aux buses. You could add more program buses, and you could also add N-1 or clean feed buses here. For our presentation, so for the general setup, it's enough to have these standard buses. Every bus has also some common things, so every bus can have a label. We can call this an honor bus. This is just the label, just for internal, when we configure, we know which bus holds which signal. This could be monitoring, whatever. So the naming is up to you, what you require at this point. So we work in the training, we will work with the program 1 bus, and just to show how this is all working, and with the PFL bus. Every bus has got some certain options. Every bus, for example, the aux and the program buses can have a bus number. So if I add another aux bus, I would change this aux bus number to number 2, because if I want to produce something like a production mixer with 8 monitoring auxes, every bus should have a separate number from the others, because every bus number is a separate bus which we can address in a separate way. So every aux bus has got its own master level, for example, or every aux bus has its own send levels per channel strip. So the bus number is indicating that this is a separate bus compared to the others. Every bus can also have another format. In standard mode, we have two formats, which is the mono and stereo. So even if we like to produce a stereo bus as a standard bus, we could also set up another program bus, even with the number 1. So this is also would also be the on-air bus, for example, but it could produce a mono signal as well. So we don't need to care to mono summarize the on-airs, the stereo bus. We could also make a copy of the bus as a mono signal. And if we would have had the enhanced processing license, we could also add 5.1 buses. So if I tick the box for enhanced DSP processing and go back here to the bus system, we could also choose surround 5.1 as an option for a bus type. So we could produce at the same time from the same bus number a mono, a stereo, and a 5.1 bus. Additionally, we have some so-called signal types available. So for our training, the standard signal type is the most important. But for different installations, for different purposes, workflows, etc., we offer also other bus types. I will just call them by name. We have a voice and music bus. So this is just if you want to split up your mixing into two different signal types. So if you, best example is you want to process the voice sum. So all the signals that contain voices, like microphones or guest microphones, whatever. This signal can be processed with the voice bus, a different voice processing externally as a bus. So the complete sum is differently processed compared to the music signals, which are the others. The signals which are not voice. So in some installations this is done, different processing for voice and music signals, and then these signals are summed up together in order to have the on-air signal back again. We have also a signal type which is pretty common in most installations when you want to make off-air recording. So while the one part of the desk, like here, is on air, you could place faders into off-air mode, and this fader in off-air mode will then record an off-air recording, while the rest of the desk is on air. You can make like a live off-air recording on the same desk without interfering the on-air program. This is done with the signal type off-air. Every bus has also got some talkback sources. You can make talkback into buses. This is making sense if you have clean feeds or N-1 lines, or you want to make some talkback into aux buses. This is done with the talkback sources and the talkback conditions. Here at this point, here is the limiter we already saw in the signal flow. Here you can enable that for example, the PGM1 bus has got the limiter enabled. So this is the internal limiter. It will take place at 0 dB internal. So this is the threshold we can set up here. So if the level is above 0 dB internal, the limiter will take place and start acting. So depends on what to set here. Here we have a release time, very fast limiter release time, or a very slow release time of the limiter. Standard is disabled, but you can definitely enable it if you require a limiter at this point. So this is our bus system right now. I will remove all the buses we don't require for the training right now. Yeah, so this you have here. There are also some mixer related options here. You can enable the auto mix. Some other settings take place in here. Some snapshot options when you want to save mixer and channel snapshots. Here you set up which parameters should be saved when you operate with snapshots. The other things we don't touch right now in the training. So the only thing we will see with the PFL when we configure it, we will take place here at the operation mode with some words. But the most important way to set up a general mixer is the bus system here. But of course, now we have inputs, we have outputs, and we have the buses already, but we don't have any faders. So what to do? we need to configure the console. So now we are at the point where we define the mixing desk. So what the user has got and what you have there at the mixing desk in the studio. Here in my desk we have RX2 modules, and we have 2 fader modules and a central module. I will configure this like it is here on my desk. So let's return to the config and configure a console. Normally this is empty, and we can start configuring modules from the right hand side. So we have a list of available modules. So now the list is built up. We have all the different module types we offer in here. So we have MX modules, we have fader strips, we have TFTs, external TFTs, we have even the ASICs modules here, but we like to configure RX2 modules. And we start right now. We have 2 RX fader modules, RX2 fader modules. Just drag and drop in here, and we have a central module. So now we have a standard configuration already. So we have 6 faders, 12 faders, and a central module. Now you might have seen that here in the left corner we have a message and a red bar. So what does it mean? And normally we don't need to care about it, what's written here, but if this bar is red and we have a message here, we should take care, because this is telling me that there's something in my configuration which will not work if it's real. So if we would have applied the configuration won't work. And we read the message, and this is telling me hardware design is incomplete. The module is not connected to the power source. When this is written down here, such a message here, it's always worth to check the hardware setting, because we did not touch it here, but we added new hardware to our configuration. And there's one important thing we need to do when we start a configuration, or when we set up a configuration. Remember, I will just show the presentation. Remember, when we have the system here, like this standard system example, we have our system set up with the APC ports, and we need to tell the system at which APC port which I/O box is connected. If the APC port number 1, for example, holds an external control surface, or if it holds an I/O box, or for example on the studio, so where is the console connected and where are the APC ports for the I/O boxes? Because internally, of course, we have some signal routing, and we need to tell the outputs which options they have, which outputs are configured to this certain APC port. And this mapping of hardware components like surface modules and I/O boxes to this APC ports, this is done in this hardware tab. So this is important when you configure the system. In my setup here, the hardware surface, so the RX modules, are connected to the APC ports 1, 2, 3, and 4. Here, when we click on the APC1 port of the core, we get a list of ports that are currently available and that are not connected right now. My fader module, my central module is the 5810, and the central module is equipped with 2 APC ports for the upper display and the lower display. These are connected on my desk on APC 1 and 2. The cables are already connected, and the fader modules are connected to APC 3 and APC 4. So this is necessary to tell the system at which APC port which component is connected. And the I/O modules that I currently don't have, I can just drag and move them around. So when I send in the configuration, we see the audio system must be reloaded. I send in the configuration, and now the system expects that these components are really connected to those ports. Just let's check. I see now that this display already became working because I sent in the configuration and assigned it to the correct port. One advantage of this APC assignment system that you can define where signals are connected to which APC port is very useful, because when we extend the system later on with a concentrator, for example, or if we reconstruct something, we don't need to remove audio I/Os from our system only because we extend the system with a concentrator, for example. So if I add a concentrator to my system, like in our drawing there, the concentrator can be assigned to one of the SFP ports. And now I can reassign, for example, parts of my hardware to the concentrator, or even an I/O box like the mic headphone box or the digital I/O box. I can just move the boxes, disconnect them here at the core, and I change over to the concentrator and can connect the boxes here to other APC ports. After applying the configuration, the system expects that these I/Os are connected to these APC ports. The internal audio routing will handle this. We don't need to rename or remove signals from our I/O list. This is just a reassignment, a remapping of I/O modules or surface modules to their according APC ports. So, but we already saw, we connected the modules in our hardware setting, and the DSP capacity bar changed back to blue and telling us a valid DSP capacity. So whenever the bar is red, and whenever the bar is at 100% in red, there is something you need to take care of. You need to take care of, because if this bar is red and at 100%, there is something in the config that won't let the config work on the real mixing desk. Why do we have this bar of DSP capacity? I just see, sorry, I will just save the configuration. I just forgot it. The toolbox, as I already said, is an offline configuring tool. This means you can make the configuration, you can prepare the complete configuration at home, at work, without having any DHD hardware available. Of course, it's making easier if you have the hardware, but you can make things already in advance. In order to know if the config that you did in the toolbox will be able to be applied to a core, the toolbox configuration defines and pre-calculates if the system that you are constructing will work in the real environment. So will it work with one DSP, or are two DSPs required? And when we will configure right now the mixer, we will see that the DSP capacity bar gets filled up. And the toolbox will always pre-calculate if the configuration is valid and can be run, or if it's not valid and cannot be run. And as soon as the bar is at 100%, for example, we will see that this upload knob is grayed out, because the configuration won't work. And as soon as the config won't work, we are unable to send it into the core. Now I removed everything which would prevent the config from running, and now we can again send the configuration to the core. Whenever we make changes inside the configuration, we see in the lower line here that there's a tag which is called project modified. This lets me know that our changes were made inside the configuration which are not saved to the project file. It's pretty important to know about the project file, because this is the master file of your complete configuration. If you lose this configuration file, which has got the ending dp9, you have lost all the global settings inside a project. So if you have a huge project consisting of 32 devices, for example, a huge project, and you lose a global configuration, you won't be able to restore the complete config from the single devices. So the project file is the master file of your installation, your project. So make backups of this project file and keep a backup. Save it frequently in order to have the current file always saved to your hard disk. And you also might have seen that there's a small tag here, since I sent in the configuration initially to my core. So now we have a state online written here beside this device name. And this does mean that the config I have in here in my toolbox is the same which is inside the core. If I make any changes in my configuration, let's drag again an I/O box. Let's add some audio signals. We will see that the tag here is changed from online to modified. This does mean that the changes I have inside the configuration, that the configuration I have here is different to the configuration inside the core. So this is just letting me know that there are differences between what is currently inside the real hardware and inside my configuration. Okay, let's come back to our mixing desk. We have already the modules, we have connected them inside the hardware, and now let's make the following. We need to have some signal on the fader in order to check if the mixer is working. So we will do it very rough and simple. First of all, I will show you that we have two important things to make the mixer work. We have the console with the faders. This is providing the hardware faders. After we have modules with faders inserted, we can check the channel assignment. The channel assignment is another mapping facility inside here, the configuration. Here we have a list of the 12 faders that we have in hardware. So this is what we already configured. And here we have the so-called channel assignment. And now the question is how we get signals onto our desk. This is done with this channel assignment in a standard way, but we need, of course, define the channels that are available on the mixer. So which are the signals I'd like to have in my mixing desk? And this is done with the fader channel configuration. The fader channel configuration contains all the signals that are available for the user of the mixer. So for the DJ, for the production guy, whatever. So here we make the definition which signals should be available. What do we do? In order to define channels, we can press the add button. And after we pressed add, we can set up a label for a channel. And we can assign an audio input source to this channel. So here's the place where we say which audio input will become available on the mixing desk. So here we can add now our microphones, either via drag and drop. So this is one option, how to assign signals inside our mixer, inside the channel, inside the fader channels. Or you can also add a channel, press on the select button in here, and you can just select the signal that you want to have assigned and press the assign button. My favorite way to make new channels is using the drag and drop, because then the channels are automatically created. So we can add a lot of signals here, CD player, analog, telephone. This should be also become a clean feed. So when I check the box on a certain channel, it will automatically generate a clean feed bus inside the mixer settings here. And what else for signals do we have? We have some digital signals. Codec should also be clean feed. CD player digital, some spare digital inputs. This list can be up to 250 channels long. So you have 250 choices in the bigger systems, or if it's XS2 core, then we have 150 available fader channels. So I will just add some other channels here inside the list, maybe some Dante from the 4x4, whatever. So this is what we could have here. Yeah, so we have the list of defined channels. Every channel can have its own name. And this will be also the name that the user will see later on the mixing desk. We don't care about the other settings. We already see that we have a lot of options for every specific channel that we have here. Besides the name, there are a lot of options that you could make use of as well. We will touch some of them, but there's a lot of more that can be done here. So the most important beside having physical faders and the fader channels is the channel assignment, because we need to tell the audio system, the DSP, that there are slots for processing faders. And we must do the general channel assignment. So we need to do this initially. So with the green arrow here, we take the defined channels on the right side. So these are the fader channels we already configured, and we drag them to the fader assignment. And this is the standard assignment. And already when we check the DSP capacity by every channel I assign to a fader, the DSP capacity raises a bit because the toolbox calculates now the channel processing into account. So after having added this, we have a standard channel assignment for our mixer. Now I have a problem because all of these signals are not available anymore. I have no I/O boxes here, so I will make use of a fixed processing, because here we have a sine tone generator available. And with the fixed processing, as we saw in the signal flow, we can make some certain processing, but we also have a sine tone generator available, or when you have the enhanced DSP processing license, we have also some pink noise generator in here. And yeah, let's say we make a sine tone 1K with 0 dB internally. And we can make use of this signal because we generated a new one. And probably, as I have this enhanced DSP processing license, I will also add some pink noise. I will place some digital gain afterwards because it's a bit loud. So we have also a noise signal here. And as we have an audio system, an internal audio matrix, we can use all the signals in our audio system from the audio tree as an input inside our channels. So we can even use the fixed processing as an input signal to our mixer. So here we have the sine tone, 1K, sine 1K, and here we have the noise. So for testing, this is a great tool because if you don't have the external resources available, you can just make a sine tone and test everything you configured with, even without having external signals available. And to make it easier, I will just assign the sine tone to fader number 5 as a standard setting, and let's say the noise we put on fader 12. So yeah, this is the standard things we need to do to make the mixer work. Let's send in the configuration. We are asked to reload the audio system because we made changes in the DSP. And now, of course, we don't have any buttons and we don't see if faders are in use, but normally we should now be able to hear that there are signals coming out. When I open the faders, we don't hear anything because we forgot one important thing. We already configured the mixer, but we did not do any audio routing. So we cannot hear the program bus because the program bus is not available to any of the outputs. So the last step in order to complete the complete signal flow from the input through the processing, through the bus, the last part is missing. We did not assign the audio bus to an output. What I will do right now is to configure this speaker with the program bus signal. So I will just assign the left side of the PGM bus directly to the speaker. So let's switch to I/O overview. And because we assigned this central module right now to the hardware, it appears in here. Let's give it a name. Central. ARX2 Central. So here, I/O overview. This is the audio part of the central module. And here, when we click on the module, we'll see we have the external interfaces. So microphone front is the talkback microphone of the ARX2 module, and this is the external broadcast microphone input. And here we have the speaker output, which is mono. It's a mono speaker, and we have also the line output and the headphone output of the module. So now, to complete our configuration, our audio configuration, we take the mixing function, PGM, left, because it's just the left signal right now, and assign it to the output, and we just transmit the configuration inside the mixer again. Now let's check if I did everything right. So now we should hear on the speaker, that the signal is coming out of the mixer. We remember we taught that on fader number 5 there should be the sine tone. Is this working? Yeah, it's already there. And fader 12 should have the noise. Is it there? So we already see we have a mixing desk working. So we assigned signals to the faders, and the faders are already working. But of course, what is missing right now is we cannot operate the knobs because they are not configured right now. So we can already operate the mixer because we have the faders, we have the signal, we have some output routing. So the mixer in its inner configuration is already ready. So we can already produce a program from here, but the user cannot see what we are doing, so what he will be doing. So he doesn't know which signals are on the fader, etc. So we will need to configure this in the next session. So yeah, I think this is a good point to make the lunch break right now. So first of all, are there any questions? Please place them in the chat. We will be available, of course. And what will happen now? This was the first part of the training. I will show the presentation again. So this was the first part of the training. So we finished right now with part number 1. And we will close the webinar after we finish this one. And the second part will take place in another webinar room. So we will provide you a link. It was also included inside the invitation. So the training will proceed at 12:30. And we will proceed with the configuration of our mixing desk. And but the training will go further in the next webinar room. Hello, welcome back to the basic toolbox training in the digital edition 2020, part number 2. In the previous version, in the first part of the training, we already configured our audio mixer. Let's take a look at the mixer where we are currently. So we configured the mixer in its very roughly. So we made the faders work. We have some input signals already put on the faders due to the channel assignment. We also are able to hear some audio signal from the speaker. And now we will proceed in configuring our mixer. So what is currently missing? Let's take a look again at the mixer. What is currently missing? Currently missing is the button configuration here. So nothing is working when I press the buttons. So we will take care about the button configuration. Afterwards, we will take a look into the TFT screen configuration. So for some first steps, how to configure the screens. Also, we will talk about a bit the central section, how to configure it. So we will take a look into all the things that are necessary to make it work. And now let's start to make the key functions work on the mixer. Let's go back into the toolbox configuration. Here we are. This is our current state. And we ended up in the console configuration. So everything about the mixer is inside the mixer node here. So this is the most important thing if I want to make use of the mixer. One thing I like to extend from the previous part is about the channel assignment, because the channel assignment is important in two ways. So the first thing is that we need a standard channel assignment on the faders. Otherwise, the DSP and the toolbox won't say that there's a fader configured and won't make any audio processing on a certain fader slot. When we did this standard channel assignment, we can make the mixer work. We already approved this. The second part that we can do in the channel assignment is the processing. Please remember the signal flow. We saw in the example that there is a processing chain. And currently in our configuration, there is no processing taking place. We just have the digital gain, the phase switch, and that's it. But of course, in our mixer, we want to make use of processing. And I show you how to set this up. Here in the channel assignment, there is another part of the window, the fader configuration window. And here on the right side, we have the available DSP functions. When I just choose one of the fader slots, I can just drag with the arrow on the left side. We can just add DSP functions into the fader slot. We can add also some subsonic filters, so everything we have available is on the right side, and the things that you are going to use in the fader strip is on the left side. So we can decide to have a subsonic, EQ filter, some compressor, some limiter. There's also, we provide expander, de-esser, de-esser 2. The difference between the both types of de-esser is that this is a very high integrated and complex de-esser filter, which takes a lot of DSP power, but it's very good configurable. Many parameters can be set up on this one. And we have the DSP cheaper de-esser 2, which is more efficient and not so complex, but it's also a de-esser. We also have an automated gain control in 2 variants. The automated gain control like this one, which is working with a reference dB internal value, but we have also a loudness automated gain control where the reference level is loudness units. We also can provide delay in a fader strip. This is a plugin which is required to have the enhanced DSP processing. This is why we have this star behind it to indicate that this is a licensed feature that you require with the enhanced DSP processing license. So now you see we have some processing integrated. Now you could argue that the order is not, can the order be like this? The DSP processing we apply in here is from top to down. In our signal flow, we had this signal flow from left to right. And here we can reorder the plugins in the way we like to have the processing going. So the signal comes in on position number 1, then it goes through the subsonic. In my example, it goes through the EQ, then compressor, then limiter. You could definitely rearrange it. In this case, the subsonic would hand over the signal to the limiter, afterwards to the EQ. So you can set up your own processing chain inside the mixer. And there was a question in the chat, and the question was about the pool. Normally, when we start the configuration like we do it right now, everything works in one so-called input pool. This is the standard way, and this is the most flexible way you can use a mixer. But with working with input pools, I will just show what will happen when I make use of those pools. We can split up the mixer in different processing parts. Let's say it like this. For example, we could decide that our microphones, I need to configure another pool. This is inside the audio. This is just a rough example. Okay, I make a pool for or complex processing, whatever. We could assign any fader channel to a certain input pool, like this one, complex, or it's better, I will just change it over. We call it microphone. So this is the microphone pool, and this would be the pool for other signals, like this one. And we can change the pool inside the fader channel definition. So each fader channel is defined to be in one pool. So it's standard way, and the normal way you put everything to pool number 1, and then you're done. If you want to split up the mixer in certain processing pools, you can do it like this. In my example, to explain how the pools do work, you can set up the microphones, for example, to pool mic. Now in the channel assignment, we see that the input pool here we use here is microphone as well. And now the meaning of the pools comes in. We can remove the processing from pool number 1. Now we see none of the faders of pool 1 has got some processing because I removed it. But the processing on the first 4 faders is microphone with certain settings. So I can have a very complex processing chain for signals of the type inside the pool microphone, for example. And I can have a very easy processing chain in the other pools. This is one part where pools are for. So especially when you have a mixer where you have just one DSP and you want to have very complex processing on some signals but not on the others, you can handle with the DSP resources a bit when you start integrating with pools. But important is, when you already know a DHD mixer, when we have, I will just add some other signals to a pool. So for now, So for now, the the mixer is not ready configured, so I can't show how the pools interact, but it's the best place to explain here. Here we have other channels inside the list. These channels can be used by the user on the surface. So when the user operates the desk, he can press, for example, access button and change the source which is on this fader. And the selection which is available, so which sources are available on a fader, this depends also on the pool. So in my example here, the first 4 faders, these first 4 faders belong to pool microphone because it's defined inside the toolbox in here. So the first 4 faders are microphone. The others are belonging to pool number 1. So here the user has only the chance to see sources belonging to the same pool. So if he has some input selection, he can press access and he would see all other sources that belong to the microphone pool. If there are no more sources, he is not able to change the input of these faders. So you could even set certain faders to the pool no pool, which does mean that this source is a unique one and can never be removed from the desk with input select. So this is the first pool, pool microphone. The other pool in my configuration is pool number 1, which is belonging to the other faders here. And every source which is belonging to the same pool, pool number 1, can be replaced here on the desk. But you will never be able to move, for example, microphone 4 to one of these faders because the pools are different. So you can sectionate your mixer into different pools and also can make parts of your mixer very fixed in order that the user is not able to change the inputs of these faders in order to have them fixed all the time. So this is about the input pools. For my demonstration, I will put again this small column here. You can always use it in order to get an overview about your settings. Press Control and then the highlighted labels here can be clicked in order to see which setting is available on which fader channel. So I will reset all these things to pool number 1 in order to have the most flexible mixer I want to have. So noise gate we put in here. So this is my processing for this training. So what is missing right now? We cannot operate the mixer because we have just faders. So let's move over to the console configuration. Here we are. So here we start configuring the mixer. Generally, every of the modules has got its own name. So this is just for configuration where that you see that this is the first fader module, fader 2. This module is already renamed to central. And yeah, let's first start with the hardware buttons. Every button inside the fader strip can be configured, so there's no scripting needed or whatever. This is just done with the toolbox configuration. Let's start with this button. For every of these buttons, we have all the same choices. So there is no restriction in choosing a key function for those keys inside a fader strip. So which functions are available inside a fader strip? Inside a fader strip, we have the following functions available. I just show a first example how to configure a button. I won't show any of, so I won't show all the different choices of button functions. There is a documentation on support.dhd.audio where we have a description of all the button functions that we provide in here. But the most important I will configure in order to make the mixer work. Everything else you can look up yourself. Yeah, so let's start with the button configuration. First, on the right-hand side, we have here the properties of a selected button. The button currently has no function, so there's nothing configured. So you could even have buttons on your desk which have no function. This is okay. One common thing which is there for all the buttons is the authorization and safety setting. Every button inside the console, every hardware button, but even located inside a TFT, inside a view, can be used together with allow user groups setting. So when you check boxes in here, only users belonging to these groups in here are able to operate this button. So you need to log in first in order to operate this button. If this button is blocked with authorization, a user which is not logged in or not belonging to the right group can press the button, but nothing will happen. So you can protect parts of your console by authorization. Protection of buttons can be done in two different ways, either with authorization groups, and the other is that you can also configure any unlock condition, which is a logic from the logic system, any GPI or a central button where you need to press this button first in order to unlock other keys having this unlock condition configured. So buttons with unlock condition can only be operated if the unlock condition is true. So if the unlock condition has a true state. If it's false, the button with condition won't work. It will be locked. So now let's use one of the first functions, one of the functions we definitely will find in any of our digital desks. This is the access function. When we compare to other digital mixers, in some it's called access, other mixers call it select. So in fact, if I have such an access button, the following will happen. With pressing access, I can modify settings of this selected channel strip inside my central view in order to make changes on this fader. We can do many things directly inside the fader strip. No problem, we can do it in the TFT view. We can do it with the buttons in here. But if you need to have more choices for input select, better view for EQ settings or whatever, you can do it with pressing the access button here. Same for all key functions is that a key function always has some lamp sources, some colorization. The access button, for example, has got two types of state. We can tell the key to be lit up in yellow currently, or choose any other color. If you like, you can also configure your own colors in order to light up the RGB keys of the surface here in a different color. I will use green for access button. We can also place in a label here. The labels are not so important on the RX2 and SX2 surface as the buttons are rubber buttons without any imprint. However, for configuration, it does make sense to have a key label on the buttons. And we can tell the key that it should be in another color when the button is not pressed. I will currently use the white color for first impression, and I will just send in the configuration to the desk. Let's just check how the console will look like. Now we see the buttons are lit up in white because I configured when the button is off, when the function is off, the button should be white. And if I press a key, it will light up in green. So this is the configuration, and I can change over the colors inside the toolbox config easily. So if I'd like to have the key when it's off in magenta, I will remove this setting. It does not look so good, but it's just to show this is the off color and this is the on color. So it's completely at your hands how the buttons do light up in the configuration. So I will choose color should be white when access is off and color should be green when access is on. So the first button is already configured, so we can access the fader. Of course, we did not do something inside the TFTs in order to modify the fader further, but we will care about the other buttons in here. On my desk here, we have already labels on the lower faders. The upper button here has got a small label sticker on it. When we deliver these consoles to you, when they are brand new, there's no sticker underneath the keys, but we deliver some small stickers that you can decide which function should be there on the key. And you can stick your own labels underneath the key. I will place a channel on-off button there. And we take this function for channel on-off from the list of channel functions. So herein, in this section, we have all the functions to modify the channel. Especially, we have the channel on-off functions in here. So there's a variety of functions to switch on and switch off the channel. I will just show you two of both. or let's just start with the standard button, which is this channel on-off function. So with this button, we can switch the channel on and channel off, independent of its fader state. We define that when the channel is switched on, it should light up red, and it should be off when the channel is off. So very clear indication for the user that he can see the channel is activated or not. Additionally, all the on-off buttons, channel on, channel off, and all the variants of this key also provide a certain logic which is off and ready and on and ready. This comes from a fader channel setting. I won't explain in deep, but there are a lot of settings for fader channels, and every fader channel has its own settings here, and one of the settings is ready signalization. For what can you use this for? Imagine a playout system which should tell the user if the channel, player A, player B, or whatever, or a slot machine or a card player tells that the card is loaded, that the next slot is loaded. Then the playout system could send a logic for this specific channel and tell the user, okay, the channel is ready, you can use it. Or let's say on a telephone fader, we have a telephone codec, and we want to signal that the line is opened and that there's a call inside the fader. The telephone codec could set us a logic in order to tell that on the telephone there's something ready. And with this ready lamp inside the on-off key, we can directly show inside the on-off key with a certain color that there's something on the fader to indicate the user that there's something prepared, that there's something ready. We keep this in the standard setting. I only take care of on and off buttons. Other functions in the channel section are a layer switch if you are working with fader layers. We also offer mute groups. Since version 9.1 in the latest versions, we have now also mute groups available. We have also a copy and paste function to copy and paste channel parameters. So this is all beyond this channel function thing. Another important part, of course, are the bus functions. The mostly used bus function is the PFL bus, of course. We want to pre-listen to signals, we want to cue them in, want to listen on our headphones what signals are there before taking them on air. So one of the most important bus functions is the PFL key, and this is why I will configure it. You configure the keys by drag and drop the key function directly onto the hardware key. And you see, you don't need to do it for all the fader strips. It's just a general thing. The lower row is always configured like this one, like you do it here. You can also use the select key together with this function key. So every user has his own procedure how to assign the keys. There are several ways to do it. The PFL function also has the general settings that we already saw, authorization, okay, and here we also have the functions that the key brings itself, so the function of the key. The PFL shows something else, which we will find in several keys as a toggle mode. What does the toggle mode do? We have three different variants of the toggle mode. We have the momentary mode of a key, we have the toggle mode of the key, and we have the timed toggle mode of the key. Momentary does mean it's just a switch, it's true as soon as I press it. I will show it to you. So lamp source is yellow if the key is on and off when the key is off. Just let's check how it's working. I will just switch over to the console. Here now we have the PFL keys. If I hold down the button, the key is yellow, it's on, and if I release it, it's off. So this is the momentary mode. So a button can work like this. In toggle mode, the button will be a switch. So pressing the key once will enable the function. Pressing the key twice will disable the function again. So now we have a toggle. The third mode is the timed toggle mode. In timed toggle mode, we have both momentary and toggle combined with each other in one single key. When I press the key a long time, it's a momentary key. If I press the key shortly, it's a toggle key. This makes sense for certain key applications, depends on how the workflow on the console is, how the users like to work with the console. In standard, I would configure the PFL key as a toggle mode. But of course, it's up to you to decide how the PFL button should work. And this toggle mode we will find also in other key functions. So this is why I generally explained the mode of toggling of keys. Now we already saw that the PFL keys, if I switch back to the console, is currently just only one single fader inside the PFL. Of course, we can't listen to the PFL because we did not configure it right now. But what if we want to have the PFL as a mixing function? So we want to have several channels at the same time in PFL. I'll show you how to do it right now. We need to return, for modifying the behavior of PFL, we need to modify some settings in the mixer because the PFL behavior is inside the mixer, so it's per virtual mixer. Here we have the tab Operation Mode. There are a lot of different options which are true for this mixer that you can enable or disable. The most important, I think, is for general setting up a mixer is the PFL options. Here you can see which options we have. PFL1 and PFL2 share nearly the same options. You can set up that the PFL should be a mixed bus, so you can enable more channels at the same time to be at the PFL. So this is the function we are currently searching for. You can also define how the reset behavior should be. Should PFL generally be disabled when a fader is opened, or should only a single channel be reset without PFL when the fader is opened? I prefer this setting, but of course it depends on your wishes on the console. There's also a return function. When the fader is open, PFL is on, the PFL signal will be discarded for the moment, but when the fader is closed, the PFL will return back to its PFL state. Generally, you could also set a PFL bus to be an AFL. So in some applications, this is required. Or AFL when fader on is also a certain option of a PFL bus. So I will set up this like this now, so PFL mix and reset channel. Let's just check on the console surface how it looks like. We can now, because of the mix feature, yes, I learned the lesson. Some settings, of course, depend on the audio system. I did not enough changes right now. I will do it right this in order to apply the PFL settings. So now we have a mix bus here. We can now add several channels to PFL because we ticked the checkbox for mixing, and opening certain faders will disable the PFL on those channels. In applications where you require that the PFL options should be changed, we offer also some key functions for the central section that you can modify the current behavior of the PFL bus during the runtime. So this is a general preset of your mixer, so it should work like in the standard setting. This is the standard way how the PFL is working, but it can be changed during the runtime by the user of the console if you configure the user that he is able to change these settings. Okay, so now we have already, excuse me, we should go here. We've already configured the most relevant keys inside the mixing desk. Let's check just a small overview about other bus functions that we offer. We have program bus switches. So you can enable and disable the signal to be sent to certain program buses. Generally, we have the signal of a fader always sent to all program buses. So if you add new program buses in a standard way, the signal is sent to the program bus. You must disable it if you don't want a signal to be sent to a program bus. Here we have keys to enable the offer mode of a fader. Here you have the aux bus switches to enable aux bus routing from a fader strip to an aux bus. You have certain channel buttons to enable the pre-post, pre-fader mode or post-fader mode for aux buses. Here you can also enable the auto-mix function. So this is inside the bus functions. If channels are producing a clean feed, there's a certain way certain buttons that you can use to modify the settings of this clean feed channel, like telephone or codec faders, where you can just directly cut the signal, so the signal which is sent to the telephone back, so the n-1. You can also change the mode between n- and n-mix, so you see send back the complete signal, the program signal, or the n-1 signal. You can also have a dedicated talkback into the CF. So if you place a talk CF button inside the mixer here, on faders that are a clean feed, you could make use of the talk function directly. A very big block of key functions in relationship to fader channels is the DSP on-off functions. We already saw that we configured a lot of DSP plugins inside our fader strip, but of course we need a way to modify these settings. So there are a lot of standard settings that we require, like phantom power setting, probably some matrixing features for stereo channels, some mono down mixing or whatever, on-off functions for subsonic, and all the other plugins that we offer are located in this section. So if you produce a view or settings for a channel strip, here you find all the functions to switch on and switch off certain functions inside this channel strip. Here is a section which is called fader functions. The fader functions is a very versatile thing. We will later see in the central section that we have a key function which is called user-defined key. The user-defined key is a key function that doesn't carry out any action on its own. It's just a button, but you can define the button on your own. So you can define how it should light up, in which color it should light up, if it should show a label. And you need to define and configure your own what the button is doing inside the configuration. And within the faders, we have also something which is like the user-defined key with a fader relationship, which is called the fader function. So this is behind these keys here, fader function keys. So specific settings from the fader channel. We also offer some snapshot functions inside the fader strip, but of course this is not all snapshot functions we offer. As we are currently in the context of a fader strip, we have only functions that make sense inside a fader strip. It doesn't make sense to load a mixer snapshot from a fader strip. This is why we offer only load channel snapshot function in here. So when we just change over the context into the central section, we will see that there are a lot of more snapshot functions. Then also we find some TFT functions. We should also call it view functions, because with functions that are related to views or TFTs, we mean that we can switch views inside the mixes. So everything which is displayed on such a display, we can change the view inside the fader or even in the central section. So this is behind TFT functions. And there are some reset functions in order to reset a channel name, for example, when you rename a channel. Or there's also a reset DSP parameter feature in order to reset certain plugins like EQ or whatever, just directly to default settings. So these key functions are from the channel point of view, so from the channel strip. When we now select a key in the central part of our mixer, like here, we have two displays in here. We have the RX2 central module. The lower display here is a bit pre-configured. So there's a small assistant which helps us to configure this part of the module, because we have the DFT display here and we have some hardware buttons in here. And this module comes also with 4 standard pages. So this is why we have invented an assistant to help you to configure all those 4 pages if you want to make use out of them. Generally, you can, with preview and edit page, you can define which page you're currently editing on these buttons. And you can also define what the default page of this view should be. Play around with this assistant. As I said, you can also make use of our standard configurations in here. So RX base config in order to make a good starting point to see how we do it in our standard configurations. However, we will just take a look into the central key functions right now. We will configure them on page number 1. And yeah, let's take a look which function we provide in the central section. Of course, also here it's okay to have no function on a key, because why you should provide keys to a user which are completely useless? So undefined keys will always be off. And here we have it. I already mentioned the user-defined key. What can the user-defined key do? Let's take a small look on it, because it's a very powerful thing, because you can do with this user-defined key, you can definitely do what you like to. If you require an external switch to switch something on or off, or you want to have a key combination of something, you can do it with the user-defined key. So the user-defined key has the option to have a lamp source. The first lamp source can, for example, be that the button is pressed on its own. So when the button is pressed, we will to have the key lighted up in red, sorry. And we can define other key colors that should be available on the key. So for example, when the key is not pressed, we can use a certain logic which is called device running. This logic is always true in our system, so the device running logic will never be 0. And where we use device running, we have an always on true state from the logical perspective. And we could say that the button should be lit up in cyan when the device is running. So this is the current off color, for example, and this is the color when I press the key. Here we see the toggle mode again. So we can define how the button should react, if it should be momentary, toggle, or time toggle. Let's just check. I sent in the configuration. Here we have it. This is the key. I can have it currently it's switched off, and if I switch it on, the button itself lights up with its own logic because it's pressed to on. And now in my logic system, like in logic functions, etc., or on GPOs, I can use this button as an output, so as a trigger for a GPO, for example. And the GPO will definitely follow the state of my key in here. Additionally, perfectly suited for TFT views, so the views in the on the desk. Also, the key could have conditional labels, so we could write in a label triggered by a certain logic. So if the key is pressed, for example, we can add another label to the key in order to guide the user. So when the logic is on, we will write another text inside the key. Currently, if there's a standard label, my own key. This is the standard label of the text of the key, and if the logic is true, we can show also another label inside the key. So this is good for indicating feedback from a telephone system. So if there's a logic telling us that there's some call coming in, I could write down with a label that somebody's calling, that I have the line, that the line is in hold. I can write it directly in the key and can set up something like a one-key operation where the key just changes its label currently depending on the state that is currently there. So the user-defined key is a very flexible thing. You can and need to define what it should do and how it should behave. So you will find this key very often in its configurations. What else do we have? We have a section of monitor functions. We will see this later on because we want to have some monitoring integrated into our mixer. Routing functions belong into the same section like the monitor functions. Also here we have some bus functions. Here we have a button for PFL reset, for example. By pressing the button, we will reset all the PFL options. So if PFL is switched on in several faders with the central key, we can hit the central key and PFL is switched off on all the faders. There's also some auto PFL, auto offer functions, so there can be a preset of faders that when I hit the auto PFL button, that all at the same time switch PFL on. So if you have, it's like a macro, yeah, you can press the key and then the channels are directly in PFL or in off-air mode, for example. The system functions are more or less outdated because we have everything inside the TFT views, so modifying these P plugins is done with encoders, and the system functions are for compatibility for MX consoles, for example. We don't require it in the RX2 service. Here we have the snapshot functions, so there are a lot more snapshot functions, loading mixer snapshots, saving mixer snapshots. Channel snapshots can be loaded from here, but there are also some certain functions that are inside the TFT in order to make use of the snapshots. Here we have all the other TFT functions in order to switch views on the central view. So everything inside here is about TFT view, showing them, modifying them. For example, showing a keyboard if you want to rename a channel. This is also done with the key function coming from this section here. In the access section, there are also some nice features like access next and previous. So for example, if you have access activated on this fader and we press the previous button, the access will switch over to this channel. If we switch over to the next channel, we can press access next button. I just see that there was a question inside the chat how to configure talkback function. I would say that we should access this this issue. So currently we cannot scope this in the training. Talkback is a very complex theme. So the question would be, for example, if talkback should be between different devices or if it should be done inside the mixer. One thing I can tell you, when we will talk about output functions later on, I think you should be, no, I want to say it like this. For example, when you want to make talkback, you can, for example, do it with user-defined keys. In order, when you press the key, something should happen on an output that, for example, the speaker has in his headphones. And in the later stage of the training, we will talk about output functions and what you can do with it. And within the output functions, there's the option that you can take a logic in order to switch a signal onto a certain output, for example. And taking user-defined keys and output functions, you can realize, for example, talkback functions. But the topic talkback is a more complex thing, so there could be talkback in many ways. And one of the things can be done with output functions. So just take a look at the output functions later on, and then you can get an idea how to do it later. Yeah, other key functions we have to modify fixed processings. So the fixed processings are not as fixed anymore, so we can even modify fixed processings later during with the surface. And also we have some other functions, some MISC functions here where we can modify the brightness of the console, resetting the mute groups. So just take a look into the list of functions that we have and that we offer. It's a real lot of things that you can do. So one important thing about the key functions I need to tell you, because when you configure key functions in the hardware or in the TFT, it's independent that there's a two-part list in here when you have a central section selected. We have a central list of buttons, central key functions that are showing this one. But you can also access some channel-related buttons when you switch the key functions list to channel list. In this case, it is possible, for example, I will show it with this key in order to make clear what it's doing. From the channel list, you can drag a button also into the central section. And with this setting here, act on fader, channel, or with access, you can choose that a button should directly act on one of the fader channels directly. So for example, I could choose the sine tone here. And now with this setting, this channel, this key will modify the channel on off state of this channel, independent where it is on the desk. And this is a good choice to make something like a remote control of certain faders from another control element. So if you want to have a small view TFT at the side of a sidekick place or a guest speaker place, then you make it just a small TFT where you have buttons to enable the microphone. And even if the speaker there has got no faders at its desk, he can switch on his microphone on its own, for example. So let's just send in the config and take a look how it's behaving. And now here is the sine tone key, this one, and now these buttons work in parallel. So here I have a remote control of this certain fader. Okay, now we have saw you have seen all the key functions. So we can do a lot of things with our toolbox configuration. And this is why it's called Toolbox, because it's just a real big thing that you where you have a lot of options to configure. Of course, you won't need any of the features that we have inside. It depends on your definition, how your workflow is. So in fact, you definitely need to know how the user should be able to operate at the desk. But if you know how the mixer should work, you should be able just to put in the functions that you require and to configure the things like they should be. Okay, in the next step, we of course need to define how the TFTs do behave. There's one part which is called views. A view is, I switch over here, a view is what we show on such a TFT in here. This is a view. And here we have a central view, and these should be fader views. Of course, we need to prepare some things in order to make the view working. And this will be due in the next step. As a first thing, I can prepare a central view in order to make clear how to make it work. Of course, we have also a lot of control elements for views. So this, at this side here, these are the design elements we have for view design. So we have transparency here, which is a box that can show text and that can light up by a logic condition. So this is done with a transparent, for example. We have other design elements. We won't touch all of those, but the most important we will see in the next session. I also will place a small clock element inside here, and that's it. So just, I forgot one thing. When we created a view, we need to tell the TFTs, so the real hardware, that it should show something. So here we select the view and we tell what should be the default view of this element. So I take the central view that I created, select it here, send it in, and let's just check. Now the TFT is already working. So now we could make more things with this TFT. At the last step, before we make a small break, we create another view which should contain the fader views. And for making the fader views work, we need to do some additional preparation. For now, let's do a small break, 15 minutes, and we will be back at 1:30. So in 15 minutes. See you soon. See you. Yeah. Hello, everybody. Welcome back to the next part of the training. So part number 5 of 6. We are still configuring our mixing desk. So currently we stopped at configuring our surface. Currently the state is that I switched just to the hardware console. Currently we have the buttons configured. Now we started to configure the central view a bit, and now we need to learn how to make the TFT views, so the overbridge TFTs, working. And I already did some preparation work, but I will show you what I did. So currently, let's turn back to the configuration in this toolbox. And now we need to talk about those TFTs in here, so those over the faders. Of course, we don't need to configure all the fader slots on their own, so one by one. Even as we saw already by the buttons, when you configure one button, all the buttons are configured. So we have another scheme inside the TFT configuration to have something like a prototype for one single fader strip, and this is just applied to all the faders afterwards. And the following steps we need to do. What I did is inside the view, we have the central view, and I just prepared the fader view. So this is the prototype of the fader view that we are going to install. And the view doesn't contain any contents anymore. Currently, just I placed in some so-called containers. We will just learn in some minutes what the container does. And I already can tell the TFT that it should show as a default view the fader view, the fader views view. And I will use the same view for all my fader modules, because I want to have shown everything the same on all the fader modules. So now let's do some more additional stuff that we require in order to make something like a fader overbridge view. So this is our view that we will use for displaying fader information, fader-related information. And one thing that I did is I placed in some empty elements which are called containers. A container is something like a subpart of a view that we can control separately. So inside this view, I made some empty containers, and now we will fill up these containers with live, so with some information for the faders. A view container is a subsection of a TFT, and for the purpose of the faders, excuse me, I need to stick in this section here. We can configure a container, which is called fader views. Every container that we configure can have an intention to be used in the central view or in the fader view. Currently, the most important for us right now is the fader view. We can define a certain width and a certain height, which is currently 35 by 135. And now when we're adding containers in our system, we can access these containers. So the section that we see here behaves exactly the same like the views section here, but as a container has a different size, a different view size, we can only configure the part of the container that has this intended size. We call this the standard view, and here we start. For example, what do you want to see as information inside our fader view? We definitely want to see the fader label. So there's an element which is called label element. With the arrow keys, Control and arrow key, we can move the element around as well with the mouse. And with the Shift key, we can control the size. Of course, we can do it with the mouse as well. So this is our label element. We can give it a function. So this is always the same procedure as on buttons as well as on TFT elements. You take the element and then you have some element specific configuration. Here we want to see the channel name. Probably this is a bit too big sized. So just align the name a bit, a certain size of the label, so like this. And yeah, this is the first thing that we might want to have inside our element. And probably we want to have a transparent inside our view in order to see if the channel is opened or not. So there is a certain part of logic that will tell us that the fader is opened. So we can just make a red stripe inside, and we use a certain generic function in order to tell the element that the logic of this fader, the fader start, is true. Fader start channel, for example. So now this is the container standard in the section fader views. So one thing we need to do, we need to make a fader view containing these containers. And I just removed the last container in order to show how it's configured. When we place in a container in here, there's an element which is called container. So we tell the view that at this point here in the config, at this position, there should be shown something which is called container content coming from the fader views. And now we already see that there's something which is taken from the fader view here. And we can place this element in here at a certain position. We can apply the size. So now the size from the view is copied directly to the container. And we just need to drag it to the correct position in our view. I already prepared the containers in here. Of course, we could copy and paste this element here with this copy and paste button. And I will just now use the multi-select feature in order to let these containers know that they also belong to the fader view section. So now one thing I'd like to explain what we are doing right now. We already see that we see here a preview of our fader views. So this is the preview currently, so it would look like on our desk as well. Move it like this. But there's one important thing we need to take into account. I prepared a small drawing. Excuse me. So here we are. I prepared a small drawing to show you what I did or what will happen in the background. So you see a black box which is called fader view. So this is what we, in the toolbox, we have made as a central view with 6 fader containers. And these fader containers show all the same content. So what we see, the fader view, here I'll just take another color. So the fader view that we have here is copied to all these certain container slots inside the main view. So we take one element and we copy it to the containers here. So now what the system does need to know in order to make use of this generic feature, what we configured is this one here. We have 2 different consoles, console views, console TFTs. The first one is for fader 1 to 6, and the second one should operate on fader 7 to 12. And we also want to see the fader views here. So we need somehow to tell the system that it should apply this fader view to those 2 TFT displays, and it should somehow calculate the fader position. And one thing we need to do in such a generic fader view when we set it up on our own, we need to tell the containers inside the main view that it should take certain fader offset numbers. So here we set up the 0, 1, 2, 3, 4, 5. So these are offsets of the fader strip inside the view. And when we now put the view, the fader view, onto a central TFT, the central TFT also has got something like a fader offset, a start fader. This one has got fader number 1 as a start. And this one has got fader number 7 as a start. And when we now add together the offsets of the system, so fader number 1 plus fader 1 plus offset 0, we have fader 1, fader 2, fader 3, and so on. So we can set up one view for the faders, and we can apply it to all the fader modules in our system. So we only need to take the work once. And this is what we did here. The only thing which is missing is to control if everything is set up right. Here's the fader offset. I need to set it up. Fader offset 1. Here we are in the configuration. So we need to set up the fader offset in the channel container, in the fader views, in the main view. Fader 1, fader 2, 0, so again, 0, 1, 2, 3, 4, and 5. So this is an offset which is existing inside the view. And here at the console, when I select the TFT, here is the fader offset. So this module is for fader 1 up to 6 because of the offset. This one starts at 7. This is the fader offset, fader 7. And here we have the offset again. 7 plus 0 is 7. 7 plus 1 is 8, and so on. So we have the same view used for this module. And now we can directly check if I did everything right. We send in the configuration, and here we see that we have several fader views. The same fader view reused as a generic generated, and here we have the faders working. We see that the light goes on when I open up the fader, so everything is working right now. In order to show you it a bit better, we can also now enable the web apps as we have enough views. Then I can show you also inside the browser. I switched over to the central section. I choose the web apps, views app, and I just enabled the faders. As I have the license, it's easy for me to show it to you. Let's open up the web page of the core. Here we have the snapshots app, but we don't want to see it. We want to have the views app. So let's check the current views. This is the fader view number 1. So as this is an international training, and there we have also some participants from Asia, etc., and where we have different characters used in their native languages, I want to make a short point here for UTF-8 configuration. So currently we have Arabic signs inside here, but we also support inside the toolbox the support of other character sets. And just as a generic thing, I will just make an example with Chinese. But of course, you could use Cyrillic or whatever. Some sets are already included without any additional things. But I will just make an example with Chinese characters that you could make use of. In the general section, we have the so-called resource files. These settings are valid for the complete project. And here, besides all, I'm sorry, I'm currently in the wrong project. I need to be here. So this is our training project. Here's the resource files. Nothing is inside is configured, but there can be pictures, etc. inside this configuration. And there's a so-called character set. When I make selection of character sets, I'm asked if the toolbox is allowed to connect to the internet, because character sets are located on our server. And this is what you can get as a character additional set for our hardware TFTs. When I speak about hardware TFTs, I mean these devices, because currently they don't know about Chinese, but with the configuration we do, the TFTs are told to use also Chinese characters, for example. Coming back to this setting, we can choose Simplify Chinese as a character set. If I select it, the toolbox will download the character set, so which is in fact a font. Within the toolbox, the complete toolbox program is UTF-8 compatible. So even without having the TFTs configured with native language characters, you can enter any language inside here. So if you want to program your configuration in Chinese with Chinese characters or with Cyrillic, you can do it, or Hebrew or whatever. This is possible. So when I did this, we can upload the configuration at a first. And when we are making use of character sets, I just switch over to the console. We will see something which is called updating resources. So in the current versions, when the TFTs get a new information like new pictures or a character set, the TFTs will show a small box where we'll write down updating resources. It's not so good to see in the camera, but the box tells us that the TFTs are currently getting a small update concerning the picture, etc. that are inside the TFT. Meanwhile, this is happening in the background. I can make a small example. I have a small dictionary because I'm not able to speak Chinese, but during the trainings I collected some information together. I really hope that the characters are okay, but there are some examples here. So we have, for example, microphone here. And now let's go into the correct configuration. And here, let's enter some Chinese here. Microphone 1, 2, and 3. And yeah, let's just apply the configuration. First, let's take a look into the web browser. It's already in here. And even on the hardware console, here above, we can see that we have Chinese characters displayed on the console. So yeah, this is a support we have inside the Toolbox 9.1. So here we are again. I don't need this project anymore. Support of native character sets. So it can be Chinese. You can also choose another character set. Also Hebrew is included, of course, as a character set. We can take a look which character sets are inside. And I think Hebrew is already included, so there's nothing special required to download in this case, because Hebrew is just inside. Yeah, let's go back to our configuration. So here is the fader view. Of course, it can take a long time to configure fader views, but luckily we can help us out when we want to get to know what can we do in the fader views. So this is why we have integrated some base configurations in our toolbox in order to give you a good starting point. So if you don't know what to configure or how you can configure things, how we do it in standard configurations, so what the way is to do it, we provide you a lot of projects that are standard projects for us. So one of the parts is the RX standard project, RX2 standard project. So here the RX is pre-configured with fader views, central views, some fader stuff. There's also the audio system more or less ready. So you can start with this configuration if you don't know where to start. And so I'm a bit lazy right now. Also, we also have not enough time to touch everything in detail. So we make use of the standard configuration, and we can copy this view from this configuration up to our configuration inside the fader views. Paste. This takes a moment in order to copy the view, but now we have copied a view from another device in our configuration into this mixer. If I drag the view into the uppermost position here, this becomes automatically the standard view for my console. Sending in the configuration will directly show us what happens. Okay, uploading the configuration takes a bit longer right now because I have the Chinese character set enabled. I will just remove it in order to speed up the upload of the config. But now we see we have now another TFT view inside here for the console. Taking a look into the console surface, we already see that we have the view available, and we have now also ppm. We see the level which is going on the fader strip. So let's take a deeper look into this TFT view, what we did here. So this is an example that we could make use of, and if you are completely stuck, or if you want to know how this is done, please open up the standard configuration in your toolbox. It's just inside, and take a look into the configuration of this system. So here we are, this is the view, and in the toolbox, this view looks like this. So some more words about the elements that we are using here, so some short look through. Generally, these are the elements that are available inside a fader view. So transparent we already get to know, so we can show any state of a logic, and we can turn transparent into a color if the logic is true, and we can use it as a label as well. Then we can have buttons. We already know the buttons because the button is just like a hardware button, but it's just inside the TFT, so we can place any of the functions I already explained also inside the fader strip. No problem. So here we have the key functions that are for the central, for the channel strip. Of course, we want to see some level inside our inside our view, right? So here we have the peak meter. So this is a very important element because we have a mixing desk and we want to see the levels as well, and we want to know that if there's a level in the input and how it does look like. And yeah, so this is the ppm. So you can just drag a new ppm inside, and the ppm has got some options. We can define a scale type. So there are a lot of different scale types. In our training, we keep it with German, a scale, but there are also other scales. Currently, the source can be only set to none because we did not define any level measurement, but this is good because in the fader strip, the source should be set to none because then it's automatically showing the level of the current channel strip. So this is the input signal that we are having on this certain fader strip. Additionally, there is the option to disable the scale, to disable the correlation meter. We have some peak hold option. We can also show a mono ppm just to show the left or the right channel. These are options which are common for all the ppms. Additionally, maybe only useful on central views, you can also place the ppm in this direction, so you can have it also a vertical ppm. Other options of the ppms are brand new, because the ppm can also show a certain part of our level. So in the default mode, we will always see the input level after the analog and the digital gain. If you want to have a certain peak meter, showing, for example, the after fader level, I just will enter a stereo ppm right now. And if you want to have a certain peak meter with certain options, you can also modify the colorization of the ppm, so the bar and the upper value when the red bar will be shown. You can also add some offset stuff, and we can also modify the ppm just to show, for example, fixed the input level. We can also show the ppm, the pre-fader level. So fixed, it will show the pre-fader level after the processing but before the fader, and it could also show fixed the post-fader level. Just to prove that this is working, let's just make a small check. Here we see in the meter can show both levels, input and after fader level, for example. So configuration of ppm is pretty easy. And last element we need to know, because this is pretty common for all the views. If we want to modify any sources, just a second, I will just show it here. So we have the fader strip nearly ready. We can interact with the TFT. We have on-off, we have PFL, we have a level meter. The only question is how we make use of these hardware encoders. This is done as following. There's an element which is called the encoder element. And I place an encoder element in here. Sorry, I need to switch over to the toolbox. Here is the encoder element. If I have the encoder element, of course I can resize it. And the encoder element, when I place it into the view, the encoder element, it's always working with touch. So if I don't assign any certain control, it's always a touch element. So I can operate it either in the web browser with the mouse, like this one here, or even on a tablet with a finger, or on the hardware surface with the finger. And when I want to have this interacting with the hardware encoder on the fader strip, I must set this to encoder number 1. If I have an MX surface, we have more encoders available. In this case, we would choose another encoder number, which are also colorized. In the RX2 and SX2, we always use encoder 1. And if this is done, like here on this example, we have encoder 1 assigned, so we can operate this value either by touch or with the hardware encoder. When operating with this encoder element, there are a lot of DSP functions that you can control. So nearly every parameter that we have available in the EQ, in the subsonic, etc., can be made accessible with these encoder elements. So this is the element that you can configure with the color, etc., is the element to operate parameters inside the DSP processing. So, for example, gain from the EQ, frequency, etc. And yeah, just take a look through. It's very there are a lot of options inside here. You can control everything with these encoders. Okay, so now we have our fader modules configured. The faders are working. Now the question is, what can we do with the central display? For which purpose do we need it? So normally we always want to see some level in the peak meter. So we want to know if there's something on the program bus. And I will show you right now how to configure something like a level measurement inside the DHD mixer. Of course, the first thing we need to have is an element which is called ppm. So we already know it from the fader value, but we need to do some additional steps in here when we want to see the program of our mixer. Just for completion, we make a small transparent and we write above, we write PGM. So this is the PGM meter. And now we need to do the following. So this is the ppm. We can also define again the colorization of this one, no problem. But as we don't want to see the fader related level of something, we want to have a certain measurement point. And this certain measurement point we need to create. And this measurement point we create inside the logic section here. There's a certain logic section which is called level detects. And the level detect is doing two things. The first thing is that the level detect measures the configured signal and produces data that we can take as a data source for the ppms in the display. The other thing is that the ppm is doing a measurement and evaluating the level and is generating a logic that we can use as a silence detector, for example. So I will show you both of the functions. First is to configure the level detect. We make a level detect, we call it program, and we must define which signal should be measured. It can be any signal that we can measure from our audio system. We want to measure the mixing function program. So this is done like this. So the measurement point is already done. Here with the metering, this is the ballistics of the ppm meter. If you want to have a fast meter, the attack should be at 0 or near 0, and this is the release time. So how slow or fast the ppm will decrease if the level is underneath the current shown value. So there we have a table with different values that you can use to reach certain behaviors of ppms. So the value is also, the table is also in the online documentation. The standard value is 0 milliseconds and release is 0.77 seconds for release. So this is a standard value, but you can change it, of course, on your own. So this is done. We need to assign this level detect into our central view because we want to tell this element that it should show the level from our newly created level detect. This is the source PGM. So when we do this, send in the configuration. I can show you inside the web views. We need to have this view here. Here is the level meter. In the background, I will open up the fader and we will see that the level is shown and it's following my program level. So this is already done. Now let's come and configure the level detect logic. What does the level detect logic do? The logic itself, so behavior of the logic, is defined with the level detection part of the level detect here. So we can define the threshold level of the level detection logic. So if the level is above this setting here, above this threshold level, minus 40 dB, for example, the level detect logic will go on to true. So I set it to, let's say 30, minus 30. Just as an example. We have a second logic generated by each level detect, which is called correlation logic. So if there's a stereo signal, we can say if the correlation of the signal of left and right is above 0, we will have a logic true. If the correlation is underneath this value, the logic will be 0. Additionally to this, we have a hold time, which is there in order to have some interpolation of the signal. So if the signal goes off, the logic will still be true for a certain time in order to interpolate about small parts of silence inside the signal. So I set it probably to something like, let's say 5 seconds or something. And now the only thing we need to do is just, we want to see the logic somewhere. So we go back into the view and let's take a transparent. Take the element configuration, check select, and here within the list of all the logics, there's also part level detects. And we can configure the level detect like this. We can also drag and drop logics directly inside the view in order to generate quickly a transparent. So there are several ways to make a transparent available inside the config. And yeah, here we want to see if level is there, it's okay. So we can make it green, PGM, okay. This is the state that we will see. Okay, let's check. Here we have the transparent. I opened up the fader. We are below the 30, and now we go above the 30 signal, 30 dB internally, and now the PGM is okay. The level detect logic is on. If I switch off the signal, after a certain hold time, the logic will go off. because the whole time just acts. And now we have the silence here. Of course, when you want to make a silence detection, so you want to know the negative state. So if you want to know if the program is not okay. So what do you need to do if you want to invert this logic information? In this case, we will make use of our logic functions. So I show you how to invert a logic state. Here we have a logic function. We call it silence PGM. So this is one thing we can do with logic functions. A logic function creates a new logic signal inside our system, which has not been there before. So we have GPIs, GPOs, etc. We have user-defined buttons, which also create a logic inside our system. And here we can create something like a silence inversion. So we want that this logic is true and on when the program signal is not there. So when the level detect is off, we will do it like this. We have here the logic sources. We can drag any source of the logic system inside our logic function. And here we define what should be the state of the logic in order to make this logic function true. So currently in this configuration, the silence PGM logic would follow the level logic, because if this is true, this will be true. This is not what we want, because we want to invert the level of the PGM level meter. So in this case, we would just choose the flank type off in here. Or other way around, we can configure it like this. When the level 1 PGM logic is off, we want to have it inside our logic. And if this is off, this logic will go true. So we have inverted this logic level into a silence logic. Again, let's place this logic in here. So now we have something like a traffic light, inverted traffic light. Check again, it's working the other way around. So you have the signal above 30, PGM OK. And after the whole time of the level meter, of the level detect logic, it will turn to silence. And this would be the case where you want to ring an alarm or something else. So this logic is something that you probably like to monitor, so that you know that there's silence. Or when you have this information, you probably want to switch over to a rescue program, want to trigger a rescue player or whatever. So this is what you can do with logics. You can invert them and you can create any state that you want. Yeah, of course. Are there other questions currently? Okay. Then we can proceed. Yeah, okay. What we did right now is that we have now a working mixer. So we can see level in the mixer. We can detect silence with our mixer. We can create logic states. So we just started to create logic states. But we did not care about monitoring, for example. So let's start with a bit of monitoring right now. And yeah, first, as a first step, we want to configure something for this small monitoring Q speaker. Currently, it's currently in the state. It's currently in the state where is the module that we have just the program signal configured on this output. And now we want to make some changes onto this output in order to configure it in a way that it will have some leveling, for example, with a potentiometer, and that we have probably a mute switch on this output in order to have the speaker muted if the microphone is switched on. I think I just take a small look at the time, and we have only 10 minutes for what I wanted to show you in the next part. We require more time. I will just postpone this to the next session, to the next part of the training. I will do something else which fits exactly in the following 10 minutes, because there is something else very, very useful inside the toolbox. So we will just take another look inside our configuration, but not on this part. We will just take a small look at the utilities bar above here, because as you already got a feeling for, the toolbox configuration might be a bit complex when you have a huge project. So we have several parts where you have things in the console, located in some parts in the audio system, inside the logic system. And the question is how to find a way through the configuration. And I wanted to show you two things that are pretty helpful for configuration. This is on the first hand, this is, for example, the tagging in the documentation bar. So when we have some logics configured, for example, or if you have some things in the audio system configured, we can add colorized tags to functions that we have configured in order to mark them with the color in order to see in the config which belongs together. So if there's something which belongs to a certain signal path, like headphones, for example, or to speakers, or if there's something which is belonging to a certain switching case. So with these so-called general object tags, you can define your own tags. For example, if we make a silence detect tag inside the system, we can do it because it's on our own to configure those tags. And like we did in our example, we have something which is related. Here it is. Okay, so we have it. So this logic is, for example, related to the silence detection. So we can mark it with a certain label and tag. And also the level detect, we can also mark with silence detect because it's just making, is taking a part of it. And also the level detect, the level detect we have here is tagged with this. And additionally to this colorized documentation with the tags, with the colorized text, you can also add some item documentation. So if you have specified some logics, so more complex like those ones here, you can write down why you configured this logic function or why you configured a certain output function. So we'll talk about the output function in the next step. So if you set up something complex in your system, some logics, some more complex logics, some things that seem to be more complex, you can write down directly here why you did it. So because if a project is ready, and you normally will close the project, and probably if everything is done inside the studio and everything is running, you won't touch the configuration so often anymore. So probably once half a year or every quarter year, you will take a look into the configuration to make minor changes. But sometimes you will ask, or a colleague of you is forced to work with the configuration, and maybe he will ask himself, why is it configured like this? Here you can leave a message inside the certain function why it's configured like this. And also here inside the project history, you can leave comments why things are configured or what changes you did inside the config. This is one part. So I want to encourage you to make use of this tagging and item documentation in order to have things documented directly in the project, because here's everything happening from your desk. And also, there's something else which is called the navigator. The navigator is something like a pathfinder inside the system. So you can find out with the navigator where signals are coming from and where they're going to. Because especially in the audio system, you probably want to know if you have audio function configured. So for example, like the program bus, mixing function program bus, where is this program bus used? If you probably want to change it, or if you must remove it for any reasons, then you must know where's the signal used in my configuration. And the navigator is the helping tool to let you know where the signal is used, where it's used as a source. And for example, at the program bus, when we click on this one, here the navigator will show it in the destinations view. It will show where the program bus is used. And we learn from the navigator that the PGM is used inside the level detect as PGM left and right source, we also have the PGM used as a standard source somewhere. By double-clicking on the destination, it will hop inside the middle and onto this button. And now we see, as this one is in the middle, we see that the inputs to this level 1 PGM are those sources, and that the level PGM is going into these destinations. And when I click into this button, which is now in the middle, the toolbox will redirect us directly to this signal. And from this point again, we can see where this level detect is used. The level detect logic, for example, is used in this logic function, in the silence PGM logic function, but it's also used in this TFT banner in the central view, which we call PGM OK. By double-clicking on this, we can hop directly to this element to see this configuration. The other way around, we can always click an element and see where the source is coming from. Currently, we have the logic function silence here. We can directly hop to this one. And now the navigator is working for logics as well as for audio signals. For example, here, when I check my RX2 output, I can see, here's PGM1 configured. It could be even more complex path of audio signals. And by double-clicking here, I can just hop to this signal. And I always have an overview where signals are used. So if you are required and forced to understand where the signals are coming from and going to, the navigator is the helper for you to find where the signals are used, where are coming from, and where they're going to. So these two parts in the toolbox configuration are very helping tools. This is why we have this utilities bar. Okay, so for now, I would say we just start with this break, and but then we will restart again at 14:30 with the last part of the training. In this part of the training, in the next part, we will talk about the output function. So we have still some things to do because we need to learn what an output function is, how we configure it, what can an output function do. And of course, we need to learn a bit about monitoring, how we build some monitoring stuff for us inside our console. So this is done in the last part of our configuration. So see you in 15 minutes, and see you at 2:30. Bye. Hello, welcome back to the 6th part of the training of today. So this is the last part of our presentation of this general Toolbox Basic training. Where we want to proceed is at the point where we just configured the complete mixer surface in basic means. And now we want to make some audio configuration, some extended audio configuration by the use of output functions. As we only have one speaker here, the most of the presentation will just be around this small speaker, but we can show everything which we require to do monitoring and using output functions. So first of all, let's go into the output functions section, and let's explain what an output function is able to do. An output function is creating a new signal inside the audio system, which has not been there before. So when we take a look into the audio tree, we know from the signal flow that there are a lot of signals, and output functions are also signals in our system. But the output function is a signal that we can create on our own, and we can configure what signal is inside this output function. We can have up to 120 output functions, and with some special configuration we can even extend the number of output functions, but in standard way it's 120 output functions. A single output function is a mono signal. So in many parts of our configuration, the signals are handled in stereo, but we have the output function, which is a mono signal. So when we handle stereo signals, we will have two output functions, one for the left leg and one for the right leg. We will see this later on. So for now, we want to make some special output function for our small Q speaker here at the side. We know that the Q speaker that we have is mono, so we make a small output function which we will call Q speaker, like this. So we already have the signal here, Q speaker, and the output function is already existing. So what we could do is we could already assign this output function to this output. So we already have the signal output function routed to this output, and if we would apply the configuration, the output function would be already on the speaker, but it won't do nothing because the output function is not configured. So what do we require at this speaker output? If I switch to our console, I'd like to configure that we receive several signals on this speaker. For example, we want to have PFL on this speaker. We'd like to have probably some monitoring. So with a selector, we want to select several signals in the speaker. And of course, we want to have some volume control with this certain potentiometer here over this speaker. And we can all do this with output functions. And I'll show you how to do. So what becomes obvious when we take a look into the output function, here's a line inside the output function, which is called condition, where we write down default. And we see that the output function has a source number 1, a phase, a level 1, and it has got a source 2, a phase and a level 2. In order to understand what an output function can do at the same time at a glance, I will make a small drawing. Just a second. I prepare my draw pad. I switch over. And here we have it, okay? So what is an output function able to do? So we already saw in the toolbox that we have two separate input sources. So we have source 1, S1. This source is inside the output function. And we can have, so this is optional, we can have a second source. These sources can be mixed together. And this is the signal of the output function. In our case, this is the output function number 1. But of course, this is not everything the output function can do, because we already saw in the toolbox that there is some certain level, and we also want to have some potentiometer integrated. And the output function is able also to do this. So I will modify my drawing a bit. Every signal inside the output function is equipped with a gain, and it can be, so this is optional, and it can be also equipped with a potentiometer additionally. And now these signals are summed together and put into the output function. So with the standard way of an output function, we could now directly program to sum up the PFL signal, because this is stereo, PFL left and PFL right, sum it together and send to the speaker. Additionally, we could add the potentiometer here for this speaker in order to control the volume of this speaker. So let's do this in the configuration. Here we are. So source number 1 and source number 2, we want to sum up the PFL bus. So double clicking on the source, or alternatively, we can drag this here above. So here we have the source 1 with all the options, and we have source 2 with all the options. We like to sum up the PFL signal here. Source 1, PFL left. Source 2, PFL right. We want to sum up the left and the right leg of the PFL bus. As we are summing up signals, we normally place some attenuation here, -3 dB for the left and the right side. Some applications sum up with -6 dB, but this is up to you. So we can have some level offset with the gain, and we can also add some potentiometer in here as well. So at the same time, we can do different tasks inside one output function. To control the speaker, we'd like to use this potentiometer, which is called monitor. We can also add some rename here, monitor speaker. Min value, max value, 101 is the min value, max value is 0 dB. We can configure the limits of this potentiometer as well. So let's go back to the output function. Here we can select a potentiometer. And here we can choose from the list of available potentiometers in our system. So we have hardware potentiometers, They are coming from the module section. We can also configure inside our configuration some software-related potentiometers. So if I don't have a hardware knob for a potentiometer, I can also configure some touch-related potentiometer. Then we call it software potentiometer and can do the same things like with the hardware potentiometer with it. When you want to add software-related potentiometers, there's inside the audio section, there's a potentiometer tab where you can add potentiometers on your own, with own limits, with its own name, with its own default value. So this is an option that you have here. These sort of potentiometers you can also reuse and use inside output functions. In our case, we want to have the monitor speaker potentiometer to control the level at this certain speaker. So let's send in the configuration. We already have assigned this signal to the output. So let's see if this is working. I upload the configuration. Here we have the sine tone, here we have the noise. I activated PFL, but we don't hear something because the potentiometer is closed. I can open the potentiometer. Sounds pretty nice for us technicians. So task accomplished. We sum up the PFL and we have some volume control on the speaker. If we want to do this stereo, if we would have an output for the speakers, we would have made an output function for speaker left and for speaker right. Like this. And we can like this. So currently this is not configured, okay, but however, this is for the Q speaker. So step number 1. So now, of course, we have a problem because this is the Q speaker. It's inside the studio. We need to ensure that this speaker will not give out any signal when one of the faders is open, because we don't want to have a crosstalk between the speaker and some microphone which is inside the studio. Of course, you could say, okay, we could definitely use some red light logic that we program inside the logics functions in order to mute the speaker. Yes, this you can do, but there's an even easier and quicker way to cut signals from a certain output. And I'll show you how to do this. So here's what we do with the PFL speaker. Currently we hear the PFL. Okay, we can do it like this. Now to mute the speaker, there's something we call mute logic. There's a mute logic tabs, and here in the audio system we call it mute studio. When we have this, and we can this is just a renaming, and now we switch over to the outputs. Every output can follow so-called mute logics. So when I just take a look into the output section, except the MADI outputs, they don't do it. We want to mute the speaker output here, and here every output which is supporting the mute logics has got some checkboxes, and here we can check a box, tick a box which tells us this output should follow the mute logic mute studio. And this is a separate system beside our internal logic system. This is an internal way to mute outputs in a very quick and easy way. So this is the first part. The output should know that it follows some of the mute logics. There could even be some more mute logics at the same time. So this is up to you when the speaker should mute. And on the other way, we need to define which faders should trigger that the mute logic is on. And we do this, so the second part of this configuration, inside the fader channel config. Here we have the microphone faders and other fader channels, and some of them are inside the studio. So logically, if we assume that all the microphones are inside our studio, all those microphones should trigger the mute logic. And here we have it. Here are the output mute functions. For all the microphones, I can tick the box mute studio. And after this is done and we send in the configuration, these channels will trigger the mute function on the speaker and will definitely cut the signal on the speaker. So you can do this with all the signals that you have in order to mute signals. Let's make a check. Oh, the sine tone is also good. So now here we have the microphone faders. Opening one of the faders directly cuts the signal. So I did not configure any of the logics to mute the speaker. It's just inside the system. And so with these settings, you can easily mute speakers inside your configuration. All right, so this is how we mute speakers. So let's get a step further, because the output function is even able to do more. Let's explore the output function together with some monitoring. So before we go back and modify this Q speaker output function, we always have the task inside a studio that the presenter, for example, needs to listen to certain signals inside our system. So they need to be able to listen to PFL, they need to listen to incoming talkback, but also during they produce, they should able to be listened to, let's say, the tuner signal, which is coming back from the antenna, or to some other signals inside the broadcasting facility. So we need to have a system which enables us to pick a signal out of our current system, to put it onto the headphones, onto speakers, onto a certain Q speaker or whatever. So we will make a rough example how to program such monitoring. I see just from the chat that there was a question, can the mute function be triggered by a GPO, GPI? When you want to have signals muted with a GPO, GPI, you definitely need to use the output function. You will see later what we can do with the output function, because we have conditions here that can be used to force the output function to use another signal to send to its own output. The internal mute function that I introduced with this mute logic, this is an internal function, so you can only configure and trigger this from the fader channels and directly on the outputs. If you have the task for additional mute, you must do it with an output function where you can definitely integrate GPIs to force a mute on certain signals. Okay, so let's come back to monitoring. So we need a system, a concept, in order to pick signals from our system, in order to produce some monitoring, additional monitoring. So this was pretty easy. We are just listening to PFL, but we want to listen to the program bus. We want to listen to some other signals. And the concept to make some listening to other signals is called selector. A selector is something, just a second, I will just make a drawing for this because it's pretty easy to understand how the selector is working. I go back to our sketchpad. Luckily, there are layers. And a selector is something that we require very often in our system in order to make either routing or listening to signals, because the concept is the same. So we have a lot of sources in our system, source 1, source 2, source 3, any source. So whatever we have in our audio system, this is what we, source X, that we have available in our system. And we want to have something which is able to pick one of these signals by some certain action, by a button, for example. So a selector, in the end, is an audio signal on its own. Selector number X, so we have up to 300 selectors. So 300 selectors does mean we have 300 different signal taps that we can have in the system. And the selector is nothing else than like a turning switch that we probably know from old hardware-related installations. And the selector consists of this one here. And by triggering a selector, this does mean we press a button. The button tells that the selector number X should get listened or should get assigned to this source, for example, source number 1. And if we press another button, the selector will switch over to the other source, source number 2, or source 3, or whatever source we have. So it's like a switch, which is switching between several sources. The selector is stereo, so we can pick any stereo signal. Of course, we can make it mono as well, but the most common case is that we are working in stereo. So this is what a selector is roughly doing. And now the question is how we can pick signals with a selector. So I will show you the step how to initially integrate monitoring into your system. Let's go back to the Toolbox configuration. And the first thing is we need to have added a selector. We will call this selector monitor. We will use this signal later to have it available in our output function with this Q speaker. We can give every selector a default source. We can do it. We can just place the PGM signal inside here. So afterwards I send in the configuration. This selector will always have the PGM signal selected. Now, how we can select signals for this specific selector. One way is, and I show you it inside the views, is using a button, a certain button, or certain buttons with the so-called monitor function. It's called monitor bus. And by pressing such a button inside our configuration, when it's configured, we need to select, when I press this button, which selector should be addressed. One of these up to 300 selectors. So when I press this button, I want to configure this selector monitor. And afterwards, I need to tell the button which source it should put on the selector. So this is like a quick routing button. So press the button and the source is inside the button and also the destination is inside the button. And when pressing this key, directly we have the PGM signal routed to the monitor selector. So if I have a lot of sources, I need to do a lot of buttons in order to have all the signals available. But there's a more easy way to realize a button, a list of buttons in order to have this quickly configured. So we call this monitor list. And to make use of it, I will show how to put in place a monitoring list instead of several single buttons. In order to make use of such a monitoring list, we go back to the selector configuration. Here we see a selector source list tab. Here we can add several lists with where each list contains a number of sources that are available for the user to be listened to. We make a monitoring list. And inside the list, we can add sources that we want to be able to listen to. So we want to listen to the PGM. We also want to listen, for example, for certain inputs that are directly coming in. Let's say tuner input, maybe the CD player input. But also I prepared some special signals just for demonstration, so we can hear and imagine what's going on. I have generated several fixed processings with 560 Hz, 710 and 800 Hz. We can always rename these labels. So the list here has on one hand is a source list. On the other hand, it's also a label list. And these labels will be then shown in the automated generated list that we will see in some moments on the TFT. So PGM. Yep, so that's it. So we have configured a list. And the last step we need to do inside the selector section is that we need to tell this selector signal that it is fed by a list. Here's the source list. So now we have attached the list we created to this selector. And last step, in order to operate this selector with a list, is to add a new element, view options, button list. This is an automated element which is fed by the firmware automatically. And if we give this button list, it has got several functions. It can be used for input select, for example. Generally, it can also take over the part of monitor selecting. If you set this list to monitor select, we can say which selector it should operate. And because of the configuration and the attachment of the list to this selector, the list does know that there are several sources provided inside this selector. And afterwards, it can show these buttons. So we have some colorization options here. So these are the same. Let's take like gray as off color, so like this. And this is the button list. We can operate, we can set up the keys in here, so we can vary the size, etc. But we only want to have this as an example. Monitor list. Okay, let's send in the configuration. Let's check if the list is working. I will check in the web apps. And here we see, here is what we configured inside the list. There's, I did not pay attention to it. In the button list, we have an automated line break after 8 characters. You can, if you keep this in mind, you can either have small white space after 8 signs, or if you want to have a line break on your own, small tip from the expert, you can also add a backslash in order to force a line break inside the button list, like this one here. And here we just shorten the label. Okay, so but we will see this after I send the configuration again. So now we already see that we can move the selection here, but of course we don't hear the signal. So what is missing in order to complete the example of the selector? So what do we need to do? We go back to the configuration. And we need to go back to our output function, because here on our Q speaker, we are currently listening to the PFL. So what do? We need to just exchange the standard source of this output function. So we take the selector, which is a new audio signal in our system, so which is following the picked signal with the button. We will just place the selector signal in here, selector left and selector right, so we produce the monitor signal here. So first step. So let's just check it, if it's working. So yeah, I open up the speaker. Or the PGM. All right, so this is working. So now, of course, my configuration, we now lost the ability to listen to PFL. But here we are back inside the output function, because we can also switch sources with an output function. So what I'm going to show you, I will just show it in the sketchpad first. Here we are back inside the output function. An output function has got the ability to have several conditions. So what we already saw here, at this point, here we are. So what we already saw at this point here, we can double inside the output function, or even add other conditions. We can make, this is the default condition, we can make a new condition in here, which has got the same options like the first line in the output function. So to complete this one here, this is source 1 default, this is source 2 default. We have source 2, condition 1, source 1, source 2, condition 1. And each line inside the output function has got the same options again. So we have again a gain stage, we have a potentiometer, and the line with condition number 1 also has got the summing option. And following the condition, we have here a switch where the output of the output function is selected. So here we have now a switch which is dependent on any condition. So if we have a third condition, we have the same from here, again here, for all the conditions. And here we have a logic input which tells the output function which part of the output function should be taken, if it's the first line, the default line, or if it's one of the conditions. And here we have a logic input, and the logic tells the output function which line to take. So let's go back inside the config, because now let's complete the example with the output function. So currently we hear the selector signal. Now we want to have if PFL is activated as a logic condition. Here's the logic: PFL is on. When PFL is on, we'd like to listen to PFL. So we use the same settings from the above line and integrate the PFL left and right inside here. So we switch the signal. So now we are missing the summing with -3 dB, and we miss the monitor, because when we switch to this line, all the settings of this line take place inside the output function. So we need to copy the settings from the level and the potentiometer. So we do it a bit different, because it's easier to press Control copy, Control paste, Control V, Control C, Control V, PFL. When PFL is on, we'll just replace this signal. And now we have a signal switch inside the output function. Currently, in the standard way, we will here listen to the monitor signal, right? And now we press PFL on the noise. And now the noise signal overrides, because PFL is on, the output function will take the other line from its conditions. So when pressing PFL, this line will be active. So the output function is a signal switch as well. And here we get the turnaround to the question with a talkback. If you have a talkback signal, you could add another line in here with another condition, which could be some GPI, for example. And when this GPI comes in, you switch to this line. And here you add the talkback signal to the Q speaker. And so the output function in its own, it's a very versatile thing, because you can do a lot of things in here. And of course, when we have something about speakers and headphones, we could go also the other way. You can cascade output functions with each other. So you already saw that here at the Q speaker, we had to copy the central monitor volume control and the sum up stage. We can do this in an output function, but we could also create another output function. So the first output function for the Q speaker could also only do the signal switching, and the next output function could do only the volume control. So we can always use an output function as an input, as it's an audio signal, to other output functions. So we can cascade the output functions. So in normal systems or in current systems, you will definitely find speaker output functions. For example, let's make a small example for the speaker. Here again, we would have the selector as an input, but here we have the left. And as it's the speaker with volume, speaker volume left, we would add another potentiometer here for any speaker output. Take another potentiometer. Oh, it's the headphone. Then we change to headphone. This is just an example. Headphone volume left. And we have a good option here, which is currently not working. So normally there is a menu, a right-click menu, where you can duplicate this output function. And this will automatically generate the right-hand signal of this output function. And afterwards, we will have the right signal in here. So this is how we would do it for a signal in stereo meaning. So left signal, right signal. And here you have then the option to switch. For example, on the right headphone, you could add another line where you just switch off the selector signal, where you can add some talkback signal to the right ear for the DJ. The left ear will be untouched, so you can modify the left and the right signals independently from each other because of the output function concept. So this is what I could tell you about the output functions. So very, very powerful. When you take a look into our basic configuration, you will see already a lot of output functions, or if you have an existing project, take a look into existing project, because when you have an existing project in a studio where you could look inside and you know how the mixer is working, take the configuration and try to find out how the system is set up. So because if you know if on a certain output a signal comes out that behaves in a certain way, with the navigator you can find the source of the signal and try to find out how it's configured. Why is the output behaving like it is behaving? And normally you will end up in some output functions which are controlling the output behavior of this certain output. Yeah, so here you already see, just as another example, here in our extended configuration we have a monitor 1 left and right selector, and we put this signal inside an output function because if you want to make a change of the general monitoring signal, which is then fed to the speakers and as a copy to the headphones. So I just closed these boxes here. So the navigator tells us, for example, that this signal, monitor 1, is routed to the Q speaker output function, to the monitor speaker output function, and to the headphone output function. So this is a signal we create, and then it's split up into 3 different parts. And if you want to modify generally the signal which is sent to the speaker, to the headphone, and to the Q speaker, we do it at this stage. So this is a parted signal path where at several points we can modify the signal which is received by the other parts of the system. So the output function is a very versatile thing. The super output function, I don't need to show it. The only difference between the output function and the super output function is that the super output function can have up to 16 sources. So the output function has only 2 sources, but the super output function can have up to 16 switchable sources. So each source has got its own logic conditions. So this is the main difference here. Okay, what is still missing in our system? So what did we do? So we have learned how to modify signals for the speaker, how we can modify audio signals, how we can monitor signals. We could also set up some more level detects in order to see the signal here that we are monitoring. So we have up to 48 such of these level detects. One part, of course, we did not check until now, but we will do it because this is the last remaining thing, which is important to understand a general DHD configuration. This is the logic functions. We already used one of the logic functions in order to learn how we can invert a logic signal in our system. So this could be, the logic input could be also a GPI or GPO. It can be a GPI. However, everything which you have as a logic signal, we can use as a GPO. So we can use this as a source to a GPO. So logics can be attached to GPOs, where audio signals can be attached to audio source destinations. So generally, what is a good example for using the logic system? Generally, we are here in the logic area. So I guess most of you already know that you can either attach logics with each other with an OR or an AND function. So a good example for an OR function is the red light. So in every studio, we like to have some information if a number of faders is open. So for example, for our microphones, we want to have red light going on if one of these microphones is going on. So we can just make a new signal here, a new logic, which is called red light. And with this red light logic, we can trigger any lamp or show it on our display. And we will do this with our display. So we need to know if a fader is open. We need to know if the fader of the microphones is opened. And we can use a search function. So just open the logic window. We just type fader start, FS, for having the fader start. So there's a logic section which is called fader start channel. And this logic is always true if the fader is on and above its fader start value. And this is then the signal is really on air and open. And we can, with the OR function, we can just sum up these logics that are triggering the red light. So all the fader starts and logics that are inside this function will switch on the red light. So in this case, it will be the 4 microphone channels. In order to complete this, we will make another transparent inside, or we can use this one here because it's so big. We can just assign the logic we just created. We search for red light, here it is, and replace the device running logic with the red light logic, send in the config, and now we can see here is the transparent, and if I open up one of the faders, we have the red light logic. Of course, this is pretty simple. In a real system, we have a lot of other things that we need to take into account. So are there special combinations? What does happen if a fader is open and a special button is pressed? So there are a lot of combinations that I currently can't imagine, but will definitely appear in a project as a requirement to switch a GPO or to have a certain state shown on the surface. So another part of the configuration in the logic system is the AND function. So probably we want to have something activated if a red light and I make a certain button, just as an example. So this is a new function that we create. So this button, this logic will only be true if the following conditions are met. So I just invent some new logic state. So if red light is on and all the other conditions are also met, we want to have a certain information. So let's program another button here inside our desk. Make a user-defined button. We call it test. Oh, hurrah. Test. This button is again a user-defined button. And here we have the lamp source. And now the logic function AND will only light up if we have the test button pressed and the red light is on. So let's make a check. Let's again switch back to our view. Here we have the test button. Now let's take the logic function as a transparent. Red and button is on. So we can combine logic states with each other. And if several conditions are met, we will have this transparent lit up. I will do it with the surface here. So here is the transparent. I can press the button, but the logic is not going on because there's no fader start open because the red light is not on. So if the red light is on and I press the button, we will see that now the logic is working. So we can combine logics with or with AND. And this is just a glimpse on what you can do with the logic system. But it already shows that you can set up your own very complex logic stuff if you have certain states that you want to figure out, and if certain conditions are met, you want to do some certain action. Yeah. Especially, there's something else inside the logic tree, just to explain what it is doing. Here we have the logic delays tab. This is always good for if you have, for example, let's say you have an external GPI this is just giving a small trigger, like a flag from an external equipment. And this external equipment is only able to do a short pulse of 300 milliseconds to do something. But 300 milliseconds pulse is too short for something else. So you could use a logic delay in order to lengthen the pulse, for example. So you would use the GPI in here as a source, and you can say with no delay, the logic delay itself is a new logic again, and the impulse which is set by the logic delay is then a bit longer. So you can use the GPI as a trigger, and the impulse that is resulting from the logic delay is longer. So for example, 10 seconds. And you can also delay the logic with a certain amount of time. So you can set up some delayed logics, whatever. So this is also inside the logic system. And throughout the combination with logic functions, logic delays, you can realize a lot of logic combinations. And within the output functions, all these systems come together. So the audio system comes together inside the output function, and also the logic system comes together inside the output function, because here we switch audio signals depending on logics. Let's take a look to our training list. I have one last point on my list, and then I can also answer the questions that appeared inside the chat. So just wait some minutes until I'm finished, and then I can answer these questions. Last part is about audio synchronization inside systems. Of course, we have an audio system, and if we now imagine our system as a standalone one, so if we only have Studio One as a standalone mixer, we don't need to care about audio synchronization so a lot. Of course, we need to care about it if we have some digital integration with other systems, with other parts. But if it's standalone and just analog, I don't think that we require any synchronization. Then we only need to define if we are running in 48 kilohertz internal sync rate or if it's 44.1. So these are the synchronizations sample rates that we support. Standard is 48 kilohertz. But if we have a bigger system, or if we have external sync sources, we can make use of them in this tab here. So sync source 1 and sync source 2 are the sync sources that are available on the bigger systems. The smaller systems like 1830 core, for example, has only one sync source, so one external sync source. But the functionality is the same here. So this is the main sync source. So this is the sync source that we take if it's available. Currently, it's set to internal, so we have an internal sync generator for our system. If you have an external sync source, like a word clock generator, you would set it up like this. When we send in the configuration, the system waits for on its BNC connector to have word clock signal connected. And if it's at 48 kilohertz, we will sync onto this signal. If we have a mismatch from the incoming signal, so for example, we are running on 48, but the BNC connected provides just 44 or something else, which is aside from 48, so far away from it, we won't sync to this signal. So the sync source will be invalid in this case. So what will happen if you have sync source BNC configured and the BNC sync source is either not in sync, so far away from 48 kilohertz, so from the our internal sync rate, or what happens if the BNC is not available? In this case, we always use a fallback source. In this case, our fallback source, if BNC is invalid or not connected, we will fall back to internally or to the source that we set up here. So in this setting, for example, if BNC is not available, we will switch to MADI as a sync source. So if the MADI is available, we will take this signal as syncing to sync our system. If MADI is not available, so if both sync sources are not connected or invalid, we will take the internal sync. So our system is always synced, either to one of the sync sources, or if none of them is valid or available, we will sync to the internal source. In the maintenance page, there's also a small tag written down that you know which sync source is the current one. So this you should know if you are using systems with sync. In bigger systems, of course, it's recommended and a good choice to have external sync, because if you have setups like this, The MCR could be something like a sync master, or you have external equipment with a sync generator providing its sync to all the studios. Because in this case, if you have an external sync source above all the other devices, you can exchange audio signals between the cores with APC link or whatever. They will always be in sync. So as soon as everything is in sync, you don't need to be afraid about sync glitches, audio glitches, etc. So because this just only appears when several systems connected via digital interfaces are not in sync with each other. Okay, so from my point of view, I'm at the end of the presentation. We did learn in the last 6 sections how to set up a mixer. We did understand how we configure IOs, how we configure the hardware, what we can do inside the hardware, adding DSPs, for example, changing the core type. And we learned how to get signals on the fader, how to configure the buttons, what we can do with fader views, how we get signals onto the speaker, how output functions do work, so how we do the monitoring for headphones, speakers, etc., or program outputs, how we configure things in the TFT, how we do monitoring. So we have touched all the important parts that you will find in any DHD configuration if you take your own configuration or if you even take the standard configuration. At this point, I again like to encourage you to check out our standard basic configurations. I just opened up a new toolbox in order to show this again. Yeah, I'd like to encourage you to use to check out the basic configurations that we offer. We have the RX2 base config inside here. So this is a good example. The RX2 base config will also add some pictures into your project that you could use as well. So I did not show it in the presentation today, but there's also some support of PNG pictures in order to enhance your TFT configuration, place in the logo of your program there to make some corporate design stuff, things like that. So here in the resource section, we learned today that there can be a character set in order to support some other languages, so native language characters, but you could also have some PNG images inside here. And by adding such standard RX2 configuration, for example, you get some of the icons that we are using in our standard configurations. There's also a TX-based configuration that you can explore, so please just explore it and take your time to find all the things that we explained today in the training. And even you could, when the TX is added, I will also show you how to place an SX2 inside the configuration, that you learn how to explore the configuration. As I said, it's just the toolbox configuration, so it's an offline tool. You can try out anything. You can click around, you can destroy the configuration, remove things, add things, just find your way inside this. And if you have a demo system available, or you can get provided one by your dealer, then you can try your own to modify a configuration, probably on the base of an RX2 standard configuration, or as I just showed with the SX2 standard configuration. Just wait a second. The SX2, for example, is added with this wizard mode. So when you purchase a bundle from DHD, the SX2 bundle, it normally comes in this closed mode. So this is an easy configuration mode which you can use. So you can explore this. We have also a manual for this one online. And when you are in toolbox mode, you can extend the mode of this wizard. So you can add the extended feature mode. We will just do it. Then you can remove this wizard mode. Normally you require a license in the hardware when you want to make use of it in the real hardware, but in the toolbox you can definitely do it without any licensing required. So just open up the SX and you will find how we configured the ASIC wizard configuration, how the structure of this project is. And also here you get a lot of ideas how you can configure fader views, for example. So you don't need to build it from scratch like we did today. Just use one of the configs as a starting point for you in order to get used to the things like we configure things at DHD, views and output functions, etc. So first of all, I'd like to thank you, everybody, for taking your time and taking time in the training. I'd like to answer now the questions that appeared in the chat. So the first question I see here is, can fader starts be grouped? Grouping fader starts is possible. I will just go inside the studio configuration. Of course, we can group fader starts together. We can either do it with logic functions, grouped fader start. So this is a very fixed way how to group fader starts. And we can either group fader starts together by the fader start fader. This does mean fader start fader is only the fader itself. So this is the physical fader. So independent of the source, which is on the fader, we have the fader start from fader 1 always here, for example. If we want to have it bound to the sources, which is on the fader, I would make use of the fader start channel. So like we did for the red light, we grouped together the fader starts for the microphones. If there are other groupings necessary, of course you could make other combinations here with the fader start. This is one part you can do. Using the fader starts or grouping fader starts together can be also done in a more flexible way. We do then make use of so-called combined logics. So this is a bit advanced, and the combined logics is a system which is dependent on the fader start and a combined logic assignment inside the fader strip. Let's, for example, check the MADI channel. Here in the fader logic tab of a channel, we have a combined logic default assignment. Of course, we can also rename the combined logics somewhere in the logic tab. And you can either default assign channels to one of the combined logics or even to more. So for example, we could put together the signal to the combined logic number 1. And the combined logic is also a logic inside our system. So taking a look into the output function, into the logic function, we will see when I search for combined logic, here it is. So the combined logic is a known function inside the system. And now the nice thing about the combined logic is that we can do a default assignment here in the fader channels. So this is the default that is currently taking place when I send in the configuration. But with a certain key function inside the fader strip, we can also group together. I will just make an example with the combined logic key. There's a key function to trigger the combined logic. And I just need to tell the button that it's acting on combined logic number 1, for example. It's yellow when it's switched on. And I just will now quickly apply. There's one thing missing, of course. So just to complete the example, we have another transparent here. So we're currently at the stage where where my configuration becomes more and more ugly, but it's just for demonstration. We make this one yellow, and yeah, I send in the config. And here now we have the combined logic keys. I can switch on the combined logic buttons. And wherever the combined logic key is switched on, the logic will turn on. So this is a very flexible way. And if I remove the combined logic from the fader, it's automatically removed. So I can flexibly assign also faders with the combined logic to something like a fader start group. So this just makes sense probably on OB events or wherever you have some flexible things where you don't know when you configure the thing, where you don't know where the red light is required. So with the combined logics, you have 4 different groups of fader starts that you can group together. So this is about grouping fader starts together. So we have different options. The combined logic is the most flexible when we are using fader starts during the runtime. The other question is, what is the use for the virtual keys? This is a very good question. I'd like to try to answer it as quickly and best as possible. A virtual key, what can it do? We already learned, I switch over to our console. We already learned that we can use a finger to press a key. We can press keys on the hardware. We can press keys here on the central section. We can also press keys on the TFT. So our finger is something like a trigger. So we can use the finger to trigger a key. The virtual key, we can do the same, but we don't use a finger to trigger any key function. We use a logic to trigger the function. We show it in the toolbox config. So a virtual key can be configured in here. A virtual key is, we just add one, and the configuration we have in the virtual key is nearly the same like on the hardware or inside the TFT. So with a virtual key, we can probably, as a good example, if we would have had a talkback system, just a second, I need to do some things in order to have the talkback system available. If we would have a talkback system, a good example is if we have a talkback system and we have some external GPI in order to take part of the talkback system, how we can take part inside the talkback system. And we can do this with a virtual key. For example, we have a talk key, talkback. We want to make talkback from a certain source to a certain destination. So this is not configured right now, but this is not the task in here. And if we have the trigger logic, for example, a certain GPI coming from the digital I/O box, now instead of my finger, the logic will press the key. So it can be also any other key function from our list of key functions. It can be a user-defined key. It can be also an on-off function of a certain channel. So even with a toggle switch externally, I could switch on and off a fader, or I could put the fader into off-air mode or whatever. So I have all the key functions available here. So everything that you could do with a finger on your surface in order to try what the key is doing, you could also put inside a virtual key in order to have it triggered with a logic. So in this case, it would be a GPI. It could be also any other logic signal from our logic system, even a new logic function that we just create in order to trigger the virtual key. And whenever this virtual key becomes true, it will hold the virtual talkback key with these settings here. So it will follow the momentary toggle mode, for example. And yeah, now it's up to you in order to build in virtual keys that are triggered with a logic. This is commonly used also to switch views automatically in the background on the TFT, for example, or to reset some things. Yeah, there are a lot of examples. I think the virtual keys are one of the most powerful things we also offer inside the toolbox configuration. This is a bit advanced stuff here, but the virtual keys are very powerful in order to realize some special things. And as far as we learned, every configuration and every installation, even if it's a simple one, there's always a task which is somehow special, and we can, with the virtual keys, with the help of virtual keys, we can even enhance the functionality of the mixer even more. Okay, so I hope I answered the question well with the virtual keys to give a glimpse what you can do with it. So if you have the chance, also play around with it. So you cannot break something. if you don't pour water inside the console, this is the maddest thing you can do. But playing around in the toolbox, nothing will harm you. So yeah, feel free to use the config, explore the standard configurations. Okay, so from my point of view, it's time to say goodbye and to end the training. So from my point of view, I need to thank you for your attention. I hope the training was very useful for you. We are active also in the chat sometime. The training will also be presented then after with a link that you can review the training as well. And yeah, from my point of view, goodbye. Thank you. Have a nice evening or night or day, just where you are located. And yeah, see you soon, probably live in one of the next trainings. Okay, goodbye. See you.